Then Ashray will be taking on data analysis and Scikit-Learn and machine learning using Scikit-Learn. Moving forward, this is me. I have almost 6-7 year experience in R&D and have worked in different MLAI related problem statements. So a quick brief about ADARSI. So ADARSI is a premium global professional body of data scientists, data science and machine learning professionals. Association of Data Science will lead in the development and dissemination, implementation of knowledge, basic applied research, technology and analytics, decision making and management. So in and all, we have bunch of different you can say tools in our platform that helps you to grow in your data science career. One is our chartered data scientist. So this is a very esteemed designation to have. This makes you to stand out from the crowd and also help you to recognize yourself in a global level, because it's created by taking into different types of curriculum into consideration. We have also openly share a curriculum, what is the books that you can refer, what is the pattern of exam mock-ups, everything is covered in this exam, and that helps you to, you can do your self-study and go with the pace, and then you can appear for exam, know where you are lacking and upskill yourself eventually. With this, we also have this annual membership that give you access to our events, upcoming events. We also have our own journal, which is an ISSN approved. So we have our own ISSN associated with the journal. We also give monthly workshops. So the intention of monthly workshops is to give power to more advanced machine learning, AI, data science related technologies to all the aspiring data scientists. And also we have a career page where you can see a lot of job that is being listed there, and you can apply directly through our platform. So this is a glimpse of how it looks. So all the upcoming event will be shown on the website like this. The currently that you are attending now is Skillup. The next on we have also how to build an analytics career and the rising 2021 in May. We also give member discount. So the idea is if you become a member, we have this annual fee of $39.99, which gives you a 30% discount on CDS exam, and also to a lot of other benefits on the ADARSI platform. With this, I want to then move forward on explaining what is artificial intelligence, machine learning, deep learning. So before this, let's understand what is human intelligence and what is artificial intelligence, and how you say and what is definition of artificial intelligence. So we as a human, we learn through experiences. We learn when we have failed multiple times. We have, when we start walking, it happens that we fell many times on floor, and then we get up and try to learn again. So the way how our brain works is to learn through experiences, and then we try to create a next and then we kind of learn that. Now, how machine learns? A machine learns by looking for patterns among the massive data load, and when it sees one, it adjusts the program to reflect the truth of what it is found. So now, in a high level, a machine or a robot, you can say, learn in a manner that we provide a type of data, be it any kind of data, right? It can be an image data, text data, can be voice, a prediction, time series data. It can be of any data, motion data also. So what happens that you give this information to machine that why don't you take a look at this data and learn from this presented data, and then create features from it, and then it helps the machine to perform certain tasks. Now, the whole idea of this whole artificial intelligence is demonstrated by machines, unlike natural intelligence displayed by human animal, which involves consciousness, emotion, and emotionality. What does that mean is when we say artificial intelligence, the idea is to the artificial intelligence that we have now is simple artificial intelligence, which includes that a machine can learn as and perform tasks as close to human, but still they cannot have their own consciousness or can have their own emotional attachment to anything. So that type of artificial is still not evolved yet to the right extent. But right now we mostly work on all simple artificial intelligence, which includes the all the things that we see around, right? Your Alexa, your Siri. There are some form self-driving cars. There are some form of artificial intelligence where they can replace a human or they can perform a task as close to a human. Um, so what interesting is the field of artificial intelligence is not new. Okay, it's being there. If you go back, the first artificial intelligence machine that is even created is 350 But what we do is we kind of then try to be within the definition, try to create the timeline of artificial intelligence, where if you see it has evolved over time, where the biggest breakthrough was when Alan Turing tried to create the um, uh, uh, a machine that can crack the code. And then in that way, that is the starting of the actual artificial intelligence, which try to replace a human to crack the encryption code. And over time, it has evolved and evolved to a level that today it is beating human on a game which is relatively very complex, something called as AlphaGo. AlphaGo is a very complex game. It can have billions, trillions of combinations, but even then it is able to beat the best AlphaGo player in the world. Um, it also gives power to create a lot of different synthetic images. So GAN is one of the application where you can think of to create data which is not even exist. So moving forward, and then we also publish. So Analytics Magazine also published a decade of AI, uh, uh, which is most defining in last 10 years how NVIDIA is creating revolutionary GPUs to the level that how all the big players, tech players are defining the new realm of artificial intelligence, how it is moving forward in future. Um, Now, moving forward, let's understand the machine learning elements, and then we also try to understand how we build a machine learning process. And then we will start looking at how we can implement this in our daily life. So in an overall machine learning life cycle, so you have data. So what happens to the data is you kind of define your data set. You have to define it is a train data, what is test data. So train and test is basically, train is that data that will allow you to train the your model. So basically a model is like a neural system that we're going to discuss in next few slides. So you train the model, and then to train the model, you need to do some level of data cleaning, data processing. So that is a step in machine learning lifecycle. And then once that is being created, what is going to happen is we then allow the machine to predict on certain data which is not seen. So what happens that we purposefully keep some set of data with us, and we allow the machine to see and learn from the data, and then we going to allow machine to look at the data that is not being learned upon, and then what is the prediction, how it's performing on the test data. So that is the validation and testing that we do. And post that we deploy it, monitor it, and there drift or anything, then we move back to training process. To keep that in more detail, let's understand from a traditional software development versus the machine learning development point of view. Now, what happens in software development? So you have a data, you have a program, you kind of combine them together, tell that to the system or a program, and then it gives you a result, right? So this is a traditional software, how a software as system performs. But what happens to machine learning is, let's say for your business, you have some level of desired result, right? So let's say you want to detect how to detect a cancerous tumor versus non-cancerous tumor, and that is going to help to triage more patient to the hospital. So what we are going to do, we are going to create a training set. We are going to train it. We create the model, and then that model will be then executed in the program. So this trained model will be then inserted inside the program. What is going to happen, that live data, the data that model have never seen, it will be tested against that live data, real world data, and do the prediction. And then we can see the result, how it is performed. To give a even deeper dive, what we are trying to say in a more detailed format is, there will be a part of data management, there is a part of experimentation, and there is a part of production deployment. And this whole thing will talk about the whole ML process, ML lifecycle. So here you have data acquisition, data preparation, then you do model deployment, training, accuracy, validation. If there is not enough accuracy, you train it, then you deploy it. And what happens that when you monitor, you happen to learn that it is not giving the right result in the real world scenario. And that is where we call it data drift or a model drift. And then we retrain the whole process again. And this is a more like a cyclic process, where once, even after deployment, you need to iteratively allow the model to learn over time. Okay, so this is more like an in-depth, long explanation of ML. Now let's see different types of machine learning, right? So your machine learning is a very broad spectrum actually, but in that broad spectrum, you can say there are three main classification that anybody can think of. So one is your supervised learning. So what does supervised learning explains about? So supervised learning is a technique where you tell the program, you tell the model that what image represent or what data represent, what is the label of the data. So basically, and you label an apple as apple, you label an tomato as tomato, you label the dog images as dog, and then you allow the model to learn from it. You allow the model to kind of learn from that data set. Similarly, you have unsupervised learning where you don't define the label at all. Basically, you give collection of lot of data sets and you tell the model, why don't you figure out yourself that what data is in which cluster, and then you kind of do the training on that basis. The next on what we have is reinforcement learning. Is an interesting technique and being used in games and making real-time decisions. So the idea of reinforcement learning is very close to what we do as humans. So in given an environment, what is going to happen, that model, we will tell a task to the model, and the model will then, if it, so if the model does the task as per the instruction, it will gain some points. And if it's not doing as per the instruction, then it will lose points. So according to the, and the idea of this whole instruction is to create the maximum score by the model. So in that way, it kind of learns over time. So let me give you a detailed understanding of that. So let's say you have an algorithm. So you create an algorithm which has the parameters, values of mathematical function. So you give a lot of data. So there are a lot of labels of the data, and then you kind of, the whole idea of any ML model is y is equals to f of x, right? So the whole idea is this. Now, what is going to happen is, in this, we also going to create with weights. So weights are basically the learned memory of the model. You can say in high level, that is how we can say. And there is also bias, plus b is the bias. So the model represented in this way, and then it do the prediction on the test data. Now, this is the story of the supervised learning. uh, so yeah, this is the above is the whole landscape of the model training, and then this is the supervised learning where we are saying for a sample 0 the expected result, the sample 1 the expected result. So basically we are telling the labels to the model, we'll feed that to the model, and then it's do the prediction, we compare against the actual values, and if there is an error we'll tell the model, hey, you did not did well, why don't you retrain yourself, why don't you learn yourself again. So it's as simple as that. When we are in our childhood days, when we used to go to early school, and then our teacher used to say that, hey, you did not got good score, you need to learn more. And that's where we kind of learn more and more and try to get better grades. And in a very similar analogy, this is how a model also learns. Now, this is more like a, you can say an unsupervised learning technique where you do a cluster of different, so you basically give or define a training set and you provide it to model. And then what model will does is according to shape, size, color, dimensions, anything which is unique about that particular data pattern, it will segregate into different bucket. So if you see, it's not only the color, but even in this, even the colors are different here. So these are purple and this is blue. Even then it's considered as one, only one bucket only. So even the shapes are different, but color is same. So it's the model that is deciding how it will able to, you know, create the data pattern, what it understand from data, and then what is predicting as per that data set. Now, let's understand the reinforcement learning. So we understood the supervised learning is basically you define a label and then you kind of divide that against a training set, you divide the data. We understood the unsupervised learning where you bucket that into different cluster. The reinforcement learning is basically the is in those lines of against a given environment. So environment is the physical world. There is an agent. So agent is nothing but your model. So what is going to happen, that model will do an action. Against the action, we will give him a reward. The model will get an reward, and then there will be change of state. Now, every time we do something, we change the state and give reward. And this will happen in iterative fashion so that the model will learn intuitively as close to how human learns. So yeah, so this is all different types of machine learning techniques. Let's understand the building block of deep learning, and that is the neural network. So neural network is as close to how your brain works, right? The neurons in your brain kind of connected mesh of a lot of information being transmitted almost in no time. It's in nanosecond transmission rate, and be able to see how fast we take action in our day-to-day life, right? So assuming that we are trying to replicate how a human brain learns, what we have done in the past, or what human race or scientists have done in the past, they have created a perceptron. So perceptron is a single layer of neural network. And what does that mean is, so you imagine you have only and only one neuron. You just have only one neuron. And then you want to tell the neuron that how it is, what against the data set that you're going to provide, how it is, how it's going to learn. So that is the idea. So we have created perceptron, and that is the first building block of the machine learning. The whole paradigm of machine learning started. And what happened, that what people have understood, that only one neuron will not be enough, because you cannot do much with one neuron. So what we have done is we have created a networks of neuron which has input and output layer. So input layer is where you define your data set, and output layer is where you have your expected result. And in between there's connected layers which helps you to differentiate between the hidden layers. Okay. So this is a representation of the neural network or deep neural network that we usually use in our machine learning problems. Now, we understood the concept of artificial intelligence. We understood what is machine learning, different type of machine learning. Then what is this deep learning? How it is different from machine learning, right? So deep learning is the, you can say, the implementation of deep neural networks. So you have more than one layers. You have more than one neuronal layers to learn something. Okay. So in this, let's say you pass an image to tell, is this a cat or dog? So what is going to happen that from the input layer, when it passes to the input layer, it's going to divide that. There will be a process of convolution. So it will break that into small pieces, and then from the activated neurons, which learned through a defined data set, it will pass through that, it will pass the information through those and then predict it's a cat or dog. And that's the whole deep learning paradigm. So deep learning paradigm is the using the deep neural network, the one that is represented here on the right side of the page, where you have the input layer, your output layer, and a lot of hidden layers sitting to be as close to brain, how a brain works. So in summary, let me do a summary of what is the whole paradigm. So what happened that initially people will, everyone in, you can say the human race started with artificial intelligence. They wanted a machine to behave and think like human. And then what happened that eventually give birth to machine learning. And machine learning is the area of training the machine with a defined data set, where you know the input, output, and the process. But deep learning is more like a black box approach, because of the fact that how the machine is learning between these layers, it's very hard to explain. And they had been an very active research on explainable AI. And the idea of explainable AI is to also understand how machine learns and understand this information to give the right output. So that's the whole pathway. And so if somebody say machine learning, so your deep learning is a part of machine learning, and artificial intelligence is in the top of the whole paradigm, and that is how it being represented as. Okay. Now, with this, let me then move on to Python programming, and let's also try to understand why Python, why not some other language, what is the need of Python, and why it is so widely used, what is the good part about it, bad part about it, and everything. So moving to Python programming. So let's start with why Python, right? So Python is a high-level object-oriented programming language. So we all know that. The good part about it is very easily adopted and very easy to learn, because it's created in a way that it focuses more on the natural language of writing the code. So basically, it's more intuitive to write Python code, and that's where it's very easily adopted and to learn. There are thousands of Python's library and framework for you to quickly get started, and that is a very, very important additional driving force for a language like Python to start with, because you don't need to reinvent the wheel every time you start from zero. You always can take help from off-the-shelf library and then start your work. The next one is in built-in data structures, and it's combined with dynamic typing. It supports for module packages which allow system modularity and code reuse. So, and that is a very good thing to have for a programming language, right? Because as you see, the machine learning whole paradigm here is a lot of iteration goes developing this model. And if it's not modular, it's going to give us a lot of pain to build a model really quickly. Now let's see what are the ways that we can get started. What are different IDs and notebook that we can use to get started with Python. Now, so the interesting part of Python is, so all this machine learning, artificial intelligence need a lot of compute power. And many times it's not ideal to run or to train the model on a CPU system. Okay. So anybody who is not a gaming, a PC gamer, or not use or not a, have been playing games on PC, and they really want to get started on their system, it's sometimes become hard because their system is not capable enough to train a deep neural network. So to solve that problem, what Google did is they created Google Colab. So Google Colab gave you a free access to GPUs and a free interface that we're going to learn in our hands-on session, how you use a Colab. So in this, you have a notebook approach. So basically, it's more like a way that you can type it in a different blocks and see the output, and then type the another block to take it the next process forward. So Kaggle is also one of its kind, where you can take part in competition. You also take part in you can use Kaggle kernel. So they also give you access to their GPUs, some level to GPU, some CPU and RAM, where you can train the model on their servers and then deploy it like that, more like a practice session. So these tools are very good to start working if you don't have a good PC. And then the good part is, let's say you get used to the notebook approach. There's something called as Jupyter Notebook, Jupyter Lab. So basically what happens that this is a local hosted Jupyter notebook. And it's very easy to set up. There's just one command to install Jupyter Notebook or Jupyter Lab in your system, be it Windows, Linux, or Mac. And then you can start using it, all the notebook files. So there's a file format for notebook is IPYNB, IPY notebook file. So IPython is the kernel, and then this notebook is where they have created this whole framework. So some of the very widely used IDEs, and why you need to have IDEs is because you have all the packages integrated in an IDE than editor. So I think every one of us has used Notepad or Notepad++. So all this is good, but when it comes to programming, once you want to take advantage of a lot of additional thing that is readily available on your the ID. So this comes in a very handy way, right? So this one analysis being done where done by JetBrains, and they have shown that many people have been graduated themselves to work from PyCharm. So they have been working PyCharm and VS Code. They are the two best Python programming IDE that is being used. And let's also understand that what is the difference between notebook and Python script, right? So what is happening here, that Python notebook is more like a playground where you want to start learning, kickstart your learning process, and try to learn from and try to learn coding and test the code and take a quick output on the go, and then reiterate on the solution, all those kind of benefits. But a Python script is more like a deployment strategy where you kind of create different script to perform certain tasks. And that is where the Python scripts come into picture. And today, most of the deployment is through Python script. In some cases, like they started using a notebook file as well, but nevertheless, then always people prefer to have Python script for their deployment. Now, let's say you have started learning all this, you kind of started Python, and then you want to test yourself. So we also have our platform as Machine Hack. So Machine Hack is a platform where you can test your skills, you can practice and test your machine learning skills. So it's you can just log in and you can sign up for any competition, any past competition or upcoming competition. You can test your skills against thousands of data scientists and machine learning engineers all around the world. So that's again a very good platform. So yeah, moving forward, let's understand the data type and operator in Python. Till now, we have understood what is Python and why it is important, what is the benefit, and how you access the Python through the IDs and notebooks. Now, let's understand the data types. So you have text type as string, numeric type int float complex, sequence type list tuple range, mapping type dictionary, set type as set and frozen set. Frozen set is basically used to fix a value within your set and it's not changing. Boolean type is bool, so basically true, false, 0, 1. And binary is basically you want to print the array in byte or byte array form. Okay. So let's get some examples here. So here is the, you can say hello world is a string. It's within the code, so it's called string. When you have integer x equals to 20 is an integer. Similarly, you have all the details. So your list and then your tuple. We will going to learn more about what is the difference between list and tuple, because maybe many people may have that question of what is the difference between the two. Then you also have dictionary, so you can create a collection of different information in a dictionary. Then you have frozen set. So basically, it's a set which is fixed and you don't want to change it. So that is where you want to use frozen set. And then you have byte array and all this information to access the Python code. Yeah. So, okay, moving forward, let's also understand types of operators in Python. So we have arithmetic operator, assignment operator, comparison operator, logical operators, identity operators, membership, and bitwise. This is where you need to understand what all operators are useful and where how you use this operator to write codes. And these are the most building block that you can think of to write your code. So let's start with arithmetic. So we are going to cover arithmetic, assignment, and comparison. So arithmetic, as we all have been using this in any other language, you have addition, subtraction, multiplication, division, then you have modulus, then you have exponential, and then floor division. Now let's go to the this type, and then we have comparison, assignment, and then we will talk about comparison. So assignment is when we given value to x equals to 5, and then you have we want x is x plus 3, we want x is x minus 3. So we are assigning the value of x with an operator to give a to get a desired output, and this is how we are going to use it. Okay, so these are all kind of operators that you can think of in your assignment. Operators. Then you have comparison operators. So if a equals to y or x equals to y, then you have exclamation not equals to, greater than, less than, greater than, equals to, less than, equals to. So these are comparison operators. What is also important is from an operator point of view, what is the precedence of the operator? What is in a given code, which comes first, right? So your comparison, identity, membership operator is all in the same line. So basically, it's the flow of your code. If equals to is before, not equal or greater than, so your equals to will take the first priority. Similarly, your exponent is the first priority. Then you have unary plus. Then you comes the multiplication, division, floor division, modulus, addition, subtraction, bitwise shift operator. So this is also important because this helps you to make your code more robust and understand from a point of what is executed first in the Python programming, right? So which operator comes first. Um, Moving forward, let me go ahead and explain about the a string, how a string works, and then we can move to the next part. This is a very simple, so the idea of this whole um, paradigm or the coursework is to explain how easy it is to get started on a data science journey. So as simple as if A is defined as A equals to the string, the value, you can say print A and you get the value output. And then if you want to access the value from the 2 to 5 index, so what happens that in your string, the values have been indexed. So H is 0, E is 1, L is 2, the second L is 3, your the fourth L is 0 and the fifth is comma. So what we are saying that give us the value between 2 to 5. So we start with 2 and end before 5. So you get LLO. And then you can also do, you can say, and string, you can change the string character. So you can update a string. So basically in that way you can give a, you can define a string using a variable and then you say convert into uppercase, it does that. Or you want to concatenate that. So what does that mean is you have two different variables and you want to concatenate into one variable, you can do that. Or you want to replace a value within in your print function. So you assign a variable in a string format and then you give the value within the string, and this is how you do that. So you define the text dot format is you with inside the age and the bracket is open, so you can allow the user to give a value to age. Now let's understand the introduction to list, and then we'll also understand the tuples. So in a string, we have all three different types. You can have a string, you can have an int, you have Boolean data type. Then you have, so in a string, you can define a multiple variables, multiple objects. So apple, banana, cherry, and then you can also define multiple integers or a Boolean. So using the list, you can also use the list to create a list of different values. So likewise, so you have to make sure that you are observing these brackets really well. So when you define list equals to, then you are just defining that as a list. But when you want to construct that as a list, so it is between the double parenthesis bracket. And in that way you convert, you can put any value and convert this as a list. And this is really important to observe. Then you have a list with string, integer, Boolean. So you have, you can have a string, you can have integer, Boolean, and then you can go on editing your string values. So what is also interesting about string is you can also append the data, you can clear a list. What is interesting about the list is you can append the list. So basically you want to add another item to the list, you can do that. You want to clear the list, you can do that. You want to copy it, you want to count the element or extend. So there are a lot of operators that is there within the Python to access the list. So similar to tuples, let me also give a general idea about tuples. So tuples is basically similar to list, but what is the difference between a tuple or where you want to use tuple is very perspective to how you are writing the code and why, and if you want the list to be changing over time, or what we call mutable, non, or it's immutable. So the idea is simple, that just the same way how we are doing that in the list, we use the square bracket. but in tuple you define it through parenthesis. But double parenthesis, and then you want this to convert to list, you can do that as well, right? So if it's a single square bracket and there are values inside, it's called a list. And if there is a double parenthesis and you want to convert this into a list, then this command will tell the Python compiler that you want to construct a list. But if you use a single parenthesis, then this is a tuple, okay? But what is also interesting that you cannot, what will happen if you have given a single parenthesis and you define this as a object, right? So in this way, it will tell you still a string. This is still a string. Reason being because you want to make a single tuple, you want to add a comma to it. Okay, so this is something you also need to, if you want to have a single value tuple, then you need to add this comma to it. Okay. Okay. So let's spend some time understanding what is a list and a tuple. So the interesting about list is it's mutable. So basically the values can be changed, can be edited, appended, it can be updated, everything can happen. But tuple is immutable, and that is the downside of tuple. Now, the good part about tuple is implementation of iteration are much faster in tuple because it's a fixed set. But on the other side, list is difficult. Operation like insertion, deletion are better performed, but element cannot be accessed in tuple because it's immutable. List, since it consumes more memory, but tuple is not. Many built-in methods are available, but tuple does not have built-in method. So like we have seen in the previous slides that they have only count and index. We can only use these two commands to do some tuple related operation, but in list you have a lot of operations to do, right? So, and then you have unexpected error and changes, and then rarely occur in tuples because it is a more the assignment of tuple within a Python compiler is very robust, and that's where it's a very rare chance that you will run into a very unexpected error while using a tuple. So, okay, so we have went through the data types, we have went through the tuples, we have went through list, and we have seen the comparison. Now let's move on the conditional statements and what are they and how they are being used, right? So conditional statements are the if else, else if, or nested if. So let's say you want to create an if condition. So let's say if your A is 200, B is 33, C is 500, and you want that if A is greater than B or A is greater than C. So you created a condition here, right? You are creating a condition that you are asking is A is greater than B or A is greater than C, right? So then even if this is true, one of the conditions true, then it will do print at the condition is true, right? So we can clearly see A is greater than B, but your A is not greater than C because C is 500. So in that way, even if at least one condition is true, it's printing at least one condition is true. Okay, but being the case here is and it will not print anything. It will not do the job, right? Now what happens that if you want to give an if else and condition to understand that what is happening. So if B is greater than A, so or B, then print B is greater than A, else print B is not greater than A. Now, this is interesting because in many coding or in many places, we want to code it in a manner where we give we kind of give the assignment to the code in a way that we want to know what is happening in terms of variable which is being output in the previous step. So you kind of define using a if-else condition so that you can access it or you can use it, right? Elif is basically within if condition, you want to define that else if A is equals to B, then print A and B are equal. So this is again a very useful command. If you don't want to use else, you can use else if, and you can define another argument within your if else condition, right? So here you are not defining, you are saying if this or else this. But here, what you're trying to do is if B is greater than A, print B is greater than N. Or you do else if where A is equals to B, then print A and B are equal. So this is useful when you want to do a check statement within your code and you want to make sure that it is how it is behaving. So nested if is where you have X is, so nested if is basically if inside a if. So if X is greater than 10, print above 10, if X is greater than 20, and also above 20, else but not above 20. So basically you're creating a nested if. So basically the idea of this is you want multiple, you want to write the code in a manner that you want to do multiple checks to your code, that if it is satisfying this condition, if it's satisfying this condition, then you print this, or you go to the next step. Okay. So this is if else paradigm of Python in a short demo. Now let's understand while and for loop. I think while and for loop are some of those loops that we have used very intensively in any of the programming language, or be it if else. So while is very well known. I think this is need not much of a introduction, because while is, as the name says, if I is less than 6, then print I. If then we are defining an condition also. If I is equals to good, then break I plus equals to 1. So now we have what all we have used. We have used an operator. We have now comparison operator and an assignment operator. So you see in the previous slide, we have learned about comparison operator, assignment operator, then you again have a comparison operator. So while I in comparison operator less than 6, then print I. So it will print till I is less than 6. But what also we are saying, if I is equals to 3, then you break and print till that point. So it just printed till 1, 2, 3. Likewise, let's say we say I is equals to 1, while I is less than 6, print I plus 1, else print I is no longer less than 6. So we're going to try all this code in our notebook as well. So we can do that as well. Now let's come down to simple. You have a list here. You want to kind of access it. You want to, for every X in fruit, print X. So you want to print all the values within a list using a for command. So you do that. And then you can keep a condition for X in fruits, colon, if X equals to banana, colon, continue, print X. So till X reaches banana, you print it, and then you kind of take it, then it runs to the for loop in that way. Okay. So let's see some of the important libraries in Python. And now post this, we kind of jump to the Jupyter notebook and try taking a look at some of the hands-on Python code and try different settings. Okay. So in some of the libraries that you need to be very aware of or want to, when you start your ML deep learning or data science journey, you need to understand how NumPy works. We're going to have the session as well, how NumPy works, how SciPy works, what is SciPy, what is Scikit-Learn, the statistical Python, numerical Python, how Scikit-Learn helps you to do different machine learning tasks. So that is also there. What is Pandas, how it is useful to take care of your data frames, what is OpenCV Python, TensorFlow, then you have PyTorch. So TensorFlow and PyTorch are the deep learning frameworks. So basically, we're also going to learn what is different paradigms of how you start deep learning using what is deep learning, and before that we're going to learn about scikit-learn. So this is the learning of deployment, but what happens to ML and DL development, right? So in your to deploy a model, you need to understand Flask. There is also a very good which is still in process called Streamlit. Streamlit allows you to learn and deploy any machine model at ease. You don't need to work on front end. You don't need to work on a lot of software engineering. It's as simple as you define some of the containers where you want to host the model, what should be the output, what happens when output comes, and then you can just deploy the ML model that you have created. Then you have Django. It's a framework in Python, web framework in Python. Dash is by Plotly. Dash is beautiful for creating dashboards and being used for many deployment as well. So before jumping to linear algebra and statistical SciPy and NumPy, let's take a look at the hands-on session on Python. Okay, let me go there. Yeah, so yeah, let me see if there is any question. So Aditya has asked, is a list or tuple, which is more ideal? Are both equally preferred? So I think Aditya have answered that. So it depends on the performance, the error, or the type of operation that you are trying to achieve. You can use either list or tuple. Okay, so now we have I hope you can see my screen, and now let's go and understand how Python notebook works. So this is a Colab framework, what you're seeing right now. This is as simple as, let me show you. You can create a new notebook, you open a notebook. So notebook is IPYNB file, it's not PY file. And so py.py is Python script, and notebook is how you use that. And the beautiful part about the Colab notebook, it is available in almost all your Gmail accounts. So you can just activate it from your Gmail account and start using Colab notebook. So let's start with the most of the one that we have used in all the codes, which is the Hello World code. I think, let me check. Okay. So so you can keep posting your questions. We can take this in the end of the session. Yeah. Okay. Then let's see how it happens. So what happens that in this you can also see you can change the environment. So what does that mean is you can have the approach to use GPU or TPU, and this is provided by Google. So if you use none, so basically it's running on CPU. If you select GPU, it's running on GPU. And there is a free tier time. So after certain hours, it breaks the run code. So you have to see that when you want to use GPU, when you don't want to use GPU. So as you see, what is happening that we have defined X is equals to a string, a value, and then we have seen it's coming as string. Now, what is happening is, let's say we want to define X equals 20, what we have done there, right? So this is int, this is float, and then, so also what is there is we can also create tuple. So we can then define it as how you create a tuple that we have discussed in the past. We have seen there. So then so we defined the tuple in that way. So this is a tuple. This is a range. So basically you can define X of what range. So you can then define this function. You can also create dictionary. Dictionary is basically collection of different attributes. You have name, age, year. You can have multiple you can define this as 2021. Then you can then do as anything anything that you want to add, you can do that. So in that way it works in you can add as many attributes in a dictionary to access it, and then you can access the dictionary. So if you want to access it, you can also do X equals 0, and then you kind of X dot. So so you can access dictionary X dot, and then you can access the index of the value X of name. So basically, yeah. So the reason why I'm trying to show you in this way is because the Python compiler works in a way that even if you try to it's very well documented in a way that it gives you an output, and it's give the right error code that what is missing, what is not there. So set, right? So we are defining a set here. Then you have a frozen set. Basically, you have define a fixed set. You don't want to change it over time. So you have frozen set. Similarly, bool, byte, you can. So till here is fine. What is interesting is you can also see the value of the byte, right? This is very useful to get the bytes. What is the value of bytes? And then you can also see the memory view. So what is the memory allocated for this value? You can see that as well, a memory index, and then you can call this memory view through the command. Now, since we have already covered this in the list, I'm just running this again. So we are defining a text value. So we define a text value, and then you kind of do that if free is in text. So basically you are doing a check within the string that if free is in this text string, so it is present. So if you can also do live, it's true. Let's say you say world is present in the text, false. So it kind of give you a Boolean output of what is present within the string. And if you want to check, so let's say if it's a long string and you want to search a value, so you can do a simple print statement, and then you can just check if it's present or not. Similarly, you have a list. So basically, you have let's see the list value. So we created a list using a square bracket that we have discussed also earlier. Let's say you want to add value, right? You want to update a list, and that is something you can see how you're going to do that. So So basically what we are doing is we are telling that after the first value, you want to add two of this value. You want to replace the second value using the value that we are providing in the list. So what it does is it replaces banana with a blackcurrant and watermelon. So this is a simple implementation of how you can update the list, or you want to insert in different ways. So you don't want to replace anything, you want to insert a value. So you can do that as well. You can just tell the index or tell the what index that you want to insert after, and then it do post that value, right? 1, 2, and then the value. So this is a high level explanation of the list. Now let's jump to tuple. We have tuple here. So we so this type is tuple. Now you want to know the length of tuple. So how many values are there in this tuple? Let's say you want to also add orange, and then you see that the value is not changed. Now, this is interesting to access the values inside a tuple. So where you define fruits equals to this value, and you want to then, if you want to access tuple again, so you kind of, you have to tell that you again need to tell green, yellow, red. You again need to give a value and then of the same length, and then do the equals to fruit. Okay, so let's say you have apple, banana, green as a tuple, and you want to access fruit, then you need to define this in this way. And then if you do a print of green, it will tell you what is being assigned as. So that is apple, yellow is banana, and cherry is cherry. Now let's start with else if, and then we'll jump on to for loop and while loop. So this is more like an introductory. This is more like to understand in a high level what all operations you can do to start your Python programming, and then you can jump on to different high level codes also. Okay. So as we have seen in the presentation as well, so we are defining an if condition. So A is 200, B is 33. If B is greater than A, then print B is greater than A. Else is A is equals to B, print A equals to B. Else if, and then else print A is greater than B, right? So it's going to go through all these three commands. Okay, so it's going to go all these three commands to understand which condition is true and to verify the condition is right or not. So obviously A is greater than B, so else condition has been printed. Similarly, you need to also understand what happens and or, like the one that we are discussing in the presentation. So if A is 200 and B is 33, then and C is 500. If A is greater than B, yes, A is greater than B, and C is greater than A, and C is greater than A, yes, that is also true. So both conditions are true, right? Okay, now A is greater than B or A is greater than C. So at least one condition is true. So or is the way that we kind of validate that. If one of the conditions is true, you can have multiple combinations of checks here. Yeah. Similarly, you want to do nested if x equals to, if x is greater than 10, if x is greater than 20, and then you kind of do it. Yeah. And about after that, let's understand for loop. So we have also seen this in the presentation where we want to access the we want to print till banana, and then after that breaks. Also, one thing that I think I need to cover in your for loop, if else, or while loop. See, so the Python as a language is very picky about its indentation. So indentation is basically either tab or space. So this is very important. So when you put a colon, you need to have a tab space, or you have to have 4 spaces through spacebar. You can select this in your editor as well. So you have to do this. You need to make sure you have the right indentation. So you cannot have break on the line of if, because you have to tell the interpreter that it is if this condition satisfied, after this you break the code. So even if you see it goes one step forward, and then you keep the print in the line of the condition, right? So only then it works. Again, if you tried putting print before, it will do banana because of it's going only one forward. Okay. So you want to get the full code executed, then you need to have that. Make sure you have the indentation really intact, and that is the core building block of your indentation versus um, so this is while loop. I think, yeah, we have seen all this in simple examples. You can also start working on this. This is very simple to get started, and also to write the code. It's as close to writing your own pseudo code where you define I is equals to 1. There is no semicolon. Unlike other languages, you define while I is less than 6, and then you define colon, and then you tell the interpreter, okay, while I is less than 6, print I. Then you define a condition. You put a assignment. I is plus equals to 1. So I is I plus 1. So else print I is no longer 6. So basically what is going to happen, this will keep printing in loop till I is less than 6. So the value which is less than 6 is 5. So it printed till 5 and post that I is no longer less than 6. Okay. Okay. I think there are a few questions. Okay, you want? Okay, maybe in the next I will use the okay. Okay, then now let's move to the other part where we kind of understand the hands-on linear algebra. And let me share my screen again. Okay. So let me, so I have a question from Shweta. So tuple and frozen set look same, but again, you have to then get into the memory allocations, the size, the speed, and what all things that you want to do. So that is where you kind of the difference lies. So some certain set of operations are available in set, but not in tuple, and likewise you need to, it's purely depend on your Python code, what type of assignment you want to do. Another question by Shweta is what is GPU and TPU? So GPU is basically your graphical processing unit, which is the NVIDIA what is leading. So you can say the cores that created the silicon level that is being created is in a way that you kind of access the code in a GPU, and then it gives you a command of um, uh, more graphical processing. So basically it parallelizes the operation to perform certain tasks. And TPU is created by Google. It's called Tensor Processing Unit. So it is designed in a way that it is very optimized to do tensor operation. So what is an tensor operation? What is tensor? Let's understand vector and matrices. So we know scalar, right? Scalar is a value, and then you have a vector. Then you have uh, vector is a single column, right? Either horizontal or vertical. It's a single value, so single column, be it a row or column. So matrix is a collection of different vectors. So basically you can see, so this can be a vector, this can be a vector, or even from 1 to 3. Okay, let me clear this. Or this can be a vector, right? So matrix is a different combination of vectors. And then tensor, this is a 2D tensor technically, okay? So 2D tensor, what does that represent? So it's a collection of different matrices, vectors to form a tensor, okay? I have number one or more than row or more than column, and that's the tensor, how it is being defined. So now let's go to matrix operations, okay? And then we are going to have the explanation of the code as well, how you do a matrix operation using Python and NumPy, okay? So so in Python, we solve the different matrix manipulation and operations using NumPy module, provide different method for matrix operation. Okay. So we have to add a two element, we have the add command, subtract. So we're going to learn all this in using NumPy, and then we can understand there. But here in theory, this is the function that we're going to call for dot multiplication, square root, sum, and then transpose. Okay. Then we have scalar or dot product. So it is defined by you have x and x1 y1 by x2 y2. So we have two vectors. So we have 1 3 5 and 4 minus 2, and then you define a function. You need to the dot product of x comma y is sum of xi yi for xi comma yi in zip of xy. So basically you define this as a function to give a output, and then when you do a dot product between these two, you get 3. Okay. So we're going to do that in Colab. Now also we'll quickly get into introduction of descriptive statistics for exploring data. So why statistic is important, and also what is EDA, what is your exploratory data analysis, that is also important. So here we have a problem. Exploratory data analysis requires to do the problem framing. So if you don't analyze the data, you don't do the data mining, you will never understand what is the problem that you're solving, or what is the model is needed to create to solve the problem. Then you need to require and use of summary statistics, data visualization. So you require the use of summary in statistics, data visualization. So this is also important to understand your data, to summarize the data in some visualizations that we're going to have in our data visualization module. Then we have data cleaning requires an use of outliner, detection, imputation, and more. So basically, imputation is a technique where, let's say if you have missing data, or let's say you have a lot of data, multiple columns of data, and some of the data is missing. So you impute the data in a way that you either fill the data with 0 or you take the mean. So there are other libraries that helps you to impute the data to make it more robust and more insightful. Then data selection, so to use data sampling and feature selection methods. Then you have requires the use of data transform, scaling, and encoding. So data preparation is also important because the data preparation talks about if there is any transformation of data required or any scaling is required in that way. Then after you process the data, then you need to do model evaluation. Then you define your sampling method, resampling method, experimental design, and then you also kind of do a model configuration. So basically, an statistical hypothesis test or estimation of statistics. So all this are required. All these steps are required before you kind of start your data science journey and try to create your first model, right? So first is your formal framing, then you do data understanding using visualization, you do data cleaning, then you do data selection. You select a sample of data which is required for you to train the model. Then you do data preparation. So basically you transform the data in such a way that it's easy to train, and that is where the data preparation steps come into picture. Then you do model evaluation, and then configuration. You create your hypothesis, you create a hypothesis test, and then you do a selection, and then do a presentation and prediction in the end. And then you validate that it is meeting your required output or not. So this is why statistics is important for your machine learning journey. And again, statistics are very core to data science and machine learning. So you have to learn this moving forward, because without understanding data, without understanding the evaluation hypothesis, null hypothesis, you cannot actually create a good model, or you cannot get into the data science journey easily. So this is more of a explanation on the mean median mode. I think many of us has already read this in our high school, in our colleges. Mean is basically if you have different values, you kind of simply take an average and it's called mean. And then that's how we define the value from origin. So that is how you define a mean value. Mean is basically the average out value within a data set. So it's just to show that how far from origin the value lies. So let's say if the value is more on the right side, so it's the value in the data set is on the higher side of the values, and if it's on the lower side, if the values are all lower side, then it's basically the average out mean will be on the left side. Then we have median. So basically, if it's simple, right? We have read this. Median is basically given a data set, what is the middle point. If it's an odd, it's easy. If it's even, number of values are even, then it's fourth or fifth data point. Similarly to mode. Mode is the number of frequencies, interval. So basically you kind of see how many times of frequency has been, the same value is being repeated. So you kind of understand that how many times of values are repeated. So yeah, so that's the mean median mode. Now let's see the quantiles. So basically so all these are important, right? All this Mean, median, mode is important. Your statistical approach is important to data science. You need to understand the statistical approach to analyzing data and model evaluation. So let's start with the quantiles. Now you have, so these are the basic measure and segment in which the data can be shown. So these include percentile, quantile, and deciles. And that's we're going to explain that in the next slide. So what is percentile? Percentile defines the percentage of data that is present below a value of the original value. For example, if someone score a percentile of 90, so let's say somebody have scored 90, so so that the student that are below 90% of the student, is as simple that what we have been getting grades in our high school, out of 80%, 90%, 95% marks. So deciles are the 10th percentile, so which means the data point that are present below decile are 10%. So one decile, two decile, 10%, 20% in that way. Quartiles is the 1/4 of the data, which is 25%, 50th percentile, 75th percentile, and then you have 100. Then so the first quartile is 25%, second is 50, third is 75, and goes on. So you have, so this is how you divide the data. So this is important in terms of understanding and dividing the data into different chunks, and then do the analysis that is it in 2 decile, 3 decile, or is it in 10th decile, 20th decile, is it in 2 decile, 3 decile, or how it is the data is being divided into different data set. So this is an interquartile range. Interquartile range defines a difference between the third quartile and the first quartile. So it's between the effective to figuring out the outlier in the data set. So this is a very important one of the important if you want to understand the outlier understanding in the data set. So now we have variance. Variance is the measure of how distant or separate the number is in a data in a set of mean or average. So so basically variance is where variance, as the name says, like how much it's varying, right? So you can say if the variance is 0, then this indicates no deviation from mean. But if there is a variance, then you can say how much the data is varying against the mean, and that is where your variance is an important factor when the values are all one-sided, or maybe it's inclined on skewed on the one side. Then you have confidence interval. Then the confidence interval is a type of estimate computed from the statistics of the observed data. So basically, you kind of understand that what is the confidence level of a hypothesis. Is it 99%, 95%? Is it like on a lower limit? Is it on the upper limit? It's basically tells you that the hypothesis that you have created is in the right confidence level or not. And that's where it is very important to understand confidence level. So for example, you survey a group of pet owners to see how many cans of dogs food they purchase a year. So you test your statistics at 99% confidence level and get a confidence of 200 to 300. This means you think that so basically what we are trying to say that we have created a test, and we created a confidence level of 200, 300, and then we found this that it is within the 95%, which is very high level. That's your result are sound statistically right in that way. Okay. Then we have p-values. P-value are calculated probability is the probability of finding the observed or most extreme result using the null hypothesis. Again, null hypothesis is very important to create a, you can say, while defining data and your hypothesis, that what is the data when you have a very big data and you want to statistically understand the data. So you kind of do the null hypothesis is true or not. So the definition of extreme depend on how the hypothesis is being tested. P also describe the terms of rejecting null hypothesis when it is actually true. However, it's not directly probability of this state. So it's also a statistical value. If P is 0.05 or its value actually helps you to define that the hypothesis that you have created is correct or not. Okay. Then hypothesis testing is also a very important factor. So you have is a technique used to compare two data set or a sample from a data set. It's a statistical inferred method. So hypothesis testing is one of the most important technique to do it. So in hypothesis testing, what we need to do is we first need to create an assumption. You need to make an assumption. What is your assumption about the data? Then you define an initial state, and then you determine the alternate position, what could be the right, what could be wrong, and then you define your acceptance criteria. Conduct the fact-based test. So basically what the test that you are conducting is right or not. It's against a fact or not. Then you evaluate a result. So does the evaluation support the initial position? Are we confident that the result is not due to chance? So you have to kind of do all this hypothesis testing, and then each one of the following question reject the original position in the favor of alternate position or fail to reject the initial position. So basically the whole idea of statistical approach is to you kind of define it in a way that the approach that you are taking has any what is the analytical proof of that approach. So that is the whole idea of the whole hypothesis testing. So probability of observation against the set of possible result. So very unlikely observation is in this range. Then you have true value under the null hypothesis and most likely observation where you peak the graph. And then your observed result is here, which is 95% statistical significance threshold. Observed p-value after that is observed p-value statistical significance is here. So basically, yeah, so you can approve and move ahead with this hypothesis. Then there's another test called z-test. So if you see the whole landscape of hypothesis testing and p-value or confidence interval variance, all this is revolving around between the how you validate your hypothesis correct or not. And that's where these so many tests are there. There is a z-test which compares the two given sample mean and follows a Gaussian distribution. A z-test is used when the population parameter like standard deviation are known. Again, z-test depends on your standard deviation. So you kind of create your null hypothesis and there is an alternate hypothesis to that, and then you define the formula below, and then you kind of if your p-value is lower than 0.05, reject the hypothesis, else accept the null hypothesis. So your p-value is in combination to z-test, and that's where this is important if your population parameter like standard deviation are known. So what happens when you don't have you don't know that, you don't know the standard deviation, then you do a t-test. So t-test is compared between the two given group when and the assumption is the sample follows the Gaussian distribution. So the t-test is used when the parameter like standard deviation of the population are not known, and we can calculate the t statistics by the given formula. T is equals to x1 minus x2 sigma of root of n1 plus sigma by root of n2, where we have the standard deviation values, and x1, x2 are the sample mean, n1 is sample size, and then you define your t-test. Chi-square is one of the inferential statistic technique which used to formulate and check the independence of two or more variables. It's more like how is it following the null hypothesis? Is it satisfying the your null hypothesis or not? Then you have ANOVA, so analysis of variance. Basically, we know mean, we know variance. Variance is basically the it is how far away from the mean, and then we do ANOVA to analyze the how far we are from the uh, what is the variance telling it to us. Unlike t-test, it compares the variance within each sample relative to the variance between the samples, but it can be considered as an extension to t-test. So assumption, so all these tests also have their own assumptions. Like ANOVA has the data follow normal distribution and the variable of the data is same of all group. Data among groups are independent of each other. So this is an important assumption that data among group are independent of each other and the variance of data is same for all the group, and only then you can implement the ANOVA distribution. Okay, so now what we are going to do, I think I have 30 minutes more, and then Aishwarya will, so what we will do is we are going to check out few hands-on session. Let me share my screen. I hope this much Zoom is okay. Okay, so so let's start with NumPy. Okay, numerical Python. Okay, so it's as simple as so we loaded it, and then we have now going to make it an array. So you can also print A just to see what is inside A. Okay, then we want to display A. So this is another way of displaying. So one thing that is very unique about the edit notebook framework is you don't need to give any print command. You don't need to do print A. You don't need to do that. Instead, you can just, but this doesn't work in Python script, so you have to be cautious about this. So one interesting thing about the notebook is you can also save the, you can also download this as a Python file. So you can just do download.py. So this whole notebook converted into a Python script. So you can do that as well. So this is the command to display an array in more a script way. Then you have, you want to create an empty array. So this is how you do that. Then you want to create a collection of zeros. And then you also can create a collection of ones, right? Then also what is important, you also need to understand you can stack vertically. So you, let's say you have an array of 1, 2, 3, you have an array of 4, 5, 6, and you want to stack them up. So there is a command called vertical stack. NumPy dot vertical stack. So it also tells you what does vertical stack do. So you can also, while typing the code, you can also learn what is the function of this code. This function. What is the what all parameter does it need? So you define the values inside a tuple, and okay, one second. So you kind of get that shape is 2:3. Now, similarly, you can do a horizontal stack. Basically, you kind of concatenate them in one after the other. So this is simple operations in NumPy array. It can be even more complex as well, depending on the problem statement. Now let's go ahead and learn about vector. What are vectors? Okay, so we have a vector. So we kind of given this thing to 1 to 3. Let's this get initialized. Okay. Now what? So you want to do a vector addition, right? So what happens that you so for A's for now, I'm just removing this. So you define A is equals to an array, and then B is an array, and you just declare this as a value. C is equals to A plus B, and as simple as that, the vector gets added, and you get the value as 2, 4, and 6. 1 plus 1, 2 plus 2, 3 plus 3. Now you want to subtract them. So B is 0.5. So so C, so your A is 1, 2, 3, and we are defining C as A minus B, and B is 0.5, 0.5, 0.5. So you get 0.5, 1 minus 0.5, 0.5, 2 minus 0.5, 1.5, 3 minus 0.5 is 2.5. As simple as that, right? Simple. It's very simple in that way. Then you want to do vector multiplication. So this is again, since it's a in one dimension, so it's easy. But if it's a comma other matrix, then it's going to multiply. So the shape has to be same, 2:3 or 3:2. It has to be same. So then vector division. Then we have in NumPy we have dot. So we have a dot product. You can directly use a dot product. Then you have a scalar multiplication, and that's about the vectors. So here, this is what the crux is. Then you want to do a vector dot product, vector scalar product, A dot B. So A and B were given, right? So one x1 y1 plus x2 y2. So you know, right? 1 into 1 plus 1 into 2 plus 1 into 3, then 2 into 1 plus 2. So it do the dot product, and then similarly we got to get result as 14, and then you get vector scalar product. When you define a scalar and then you have a vector and then you multiply that, so you get this value. Okay. So basically 0.5 multiplied by 2, then 4 multiplied by 0.5, 6 multiplied by, so you can keep a constant scalar to multiply a whole vector. Okay. Okay. Next is next what we are going to do is we have learned what through NumPy. Now let's understand matrix. Okay. What is matrix, and then how we work with the so NumPy already have all kinds of you can say different kind. You can create different multiple matrix through the NumPy function itself. So what we are going to do is we are going to define a matrix through an array function of NumPy, and then what we are trying to tell him, you kind of do a lower and upper matrix. So basically in lower you have the values 0, 1, 0, 0, 1, 2, 0. So this, if you see from a diagonal line, so so the way we call it row because the values are present in the lower side of the matrix, and the way we say it upper, the values are present in the upper side of the matrix, and the rest of the sides are 0. Okay, that's how we tell it. Okay, now we want to create a diagonal matrix. The diagonal matrix is where it does not have a upper or lower value, it just have a diagonal values, and that's where we call it a diagonal matrix. So let me run it. So to run a notebook, the key is shift enter. When you do a shift enter, it runs the code. And what is an identity matrix is basically the diagonal values are all 1. So that we call it identity matrix. Then we have orthogonal, which we call it as 1 0 0 minus 1, orthogonal transpose. Then we have identity equivalence, inverse equivalence. So all these operations are there for different type of matrices. Now the important part is how you deal with a matrix. 1 second. So I have okay. So what I will do is I will try to complete at 2:50, and then we can have few questions if somebody wants to ask. So as simple as that, you want to do a dot product, sorry, a transpose, A transpose of T. So it's 1 3 5 2 4 6, and then we convert into 2 cross 3 into 2 cross 3 into 3 cross 2 into 2 cross 3. Okay, then numpy, then you want to take an inverse, so you can directly take an inverse of an array, as simple as this. Okay, and then you can do a dot of from the inverse. So what happens when you multiply an array with inverse, you get an identity matrix. So basically it's 0 0 0 0 0, and this is also 0 0, and then you get only 1 1 in the diagonal. Then you want to do trace. So basically you want to get the values of trace. Then you have determinant of value. You also do a rank, do a vector rank. Then you do a matrix rank. Okay. This ranking is more important when it comes to the point of you are writing a code to understand how your matrix and are defining how vectors are getting values, and if you want to rank them and see the values inside without actually going into each and every value. So till matrix operation is done, now the last one that I will be taking is on the multivariate statistics, which is a hands-on session. So in multivariate statistics, what we are going to do is in probability, the average value of some random variable x is called the expected value or the expectation. And the expected value uses a notation E with a square bracket from the name of the variable for example, E of X, it is calculated as a probability weighted sum of values. So x1 plus into p1, x2 plus p2, that is a weighted probability sum. Then we define that the expected value can be calculated as a sum of all the value multiplied by the reciprocal number of values. So basically, we are taking the mean. So basically, summation of all the values multiplied by the number of values that we have. And then so also in notebook you can also add text like this, and you can create your own documentation on your notebook. So yeah, so that's there. And then let's define mu, which is the p of x, probability of x. So in abstract, the mean is denoted lowercase Greek mu, and it's calculated from a sample observation rather than all the possible values. So mu is 1 by n. So this is the whole value. So mu is p of x into summation of all the x. So thus x is the vector observation, and p of x is calculated probability of each value. When the calculated of specific value such as x, the mean is denoted as lowercase and variable name with the line above. Okay. So let's understand this from a coding perspective. So you have a vector, you want to take a mean of a vector. So what happens that you define an array. Okay. You define an array. Okay, so this is again interesting to show you. There is only limited number of notebooks that you can run. You cannot have too many notebooks running. So what happens that it tells you to terminate all other notebooks which you are not using. Okay. It takes some time to terminate this. What is going to happen is we're going to connect it again. Okay, now let's run this. So let's see if this is true. So 1 plus 6, 7, 2 plus 5, 7, 3 plus 5, 7. So 7 plus 7 plus 21. So, but 7 divided by 2 is 3.5. So the result is the number of values is you have 6 values, and the total divided by that, we get the mean of the array that we get, right? Simple. Okay. Then you have then we have from NumPy import array, from NumPy import mean, and then you have this. Then you kind of do a column mean. So you want to take mean only in the column, and then you want to take mean only in the row. So you can easily call that mean of m, x is 0, x is 1, right? X is 0 is your column mean, x is 1 is your row mean. Okay. I hope you guys are following. This is really very simple. This is 2 cross 6 matrix. So it is 2 cross 6 matrix, and then we are taking the column mean and row mean separately. So let's understand variance and standard deviation. So variance of x is probability of e of x minus e of x whole square, which is then you can expand it to the previous function that we have created in the top, and then we define this as sigma square is equals to 1 by n minus 1 into one interesting thing about notebook also is you can write your own formulas. So you can create your own, you can type this formulas as is in markdown. So this also give you an ease to write formulas and publish these notebooks. Okay, so we have what is standard deviation is nothing but root of sigma square. So basically we have an array then we column standard deviation, row standard deviation. Okay. Then you have covariance and correlation. So in probability, covariance is a measure of joint probability of two random variables. It describes how two variables change together. It is denoted as the function covariance of x and y, where x and y are two random variables being considered. Okay, so it's as simple as that. You define this here, and you again, to calculate this, you can easily call a function as covariance. It is actually calculating variance, and then you can just call this function, and then you print the value. What is the sigma, standard deviation? Okay, sorry, variance. And then you have so likewise there are a lot of statistical techniques to do the covariance correlation techniques are there. So you just calculated covariance, which is denoted by sigma. Then you have this is small r, this correlation. So basically between the two values, how they are correlated, and covariance is how their variance are far apart from each other against a defined set. So you defined an array, you define another array, and then you want to know how their mean are far apart, or basically, so variance is the calculation of how your mean is far away. What is the value you are away from mean? So that is where you calculating covariance, and then you defining correlation, covariance matrix. Then okay. Yeah, so that's all. This is all on the covariance matrix, where you define an array and then you take the covariance within the matrix. So you kind of create a covariance of a matrix. Okay. So the idea of the whole of this presentation is not to like overburden you with multiple terms, but to tell you that all these values, you don't need to write the formula yourself. You can easily define it. These are all present within the NumPy, and you can call this function and you can get your output in one single line of code. And that is the whole essence. Similarly for covariance, row variance, column variance, or correlation, all these are there inside the library, and it's very important for you to learn the the NumPy library, the Pandas library that we're going to discuss by Aishwarya in the next session. Okay. So yeah, with this, I will like to give the, I will stop sharing, and 1 second. Yeah, Aishwarya, you can take it from here.
Yeah. Okay.
Okay.
Hello. Hi, everyone. Good afternoon. In continuation with today's session, let's move forward to the next section, that is hands-on data analysis, manipulation, and visualization with Pandas and Matplotlib. Before going deeper into how it's actually done, let's I'll give you an overview what is Pandas and what is Matplotlib. So Pandas is a just Python library. Of course, Krishna sir has discussed many libraries which are very handful when it comes to learn data science. Pandas is one of them, and it is library for data manipulation and analysis. It makes it simple to do many time-consuming and repetitive tasks associated with working with data. So eventually, data science is all associated with data, and there are many libraries which makes us easier for us to deal with them. And it is also, Pandas is also an open source that is widely used for analysis and machine learning tasks as well. So here you can see there are multiple graphs which we can plot from through this library, and of course we can create a table like data structure which Pandas has functionality for. Next is some of the features that I would like to discuss. We will discuss these function through Collab Notebook as well, how Pandas is giving access to all the functionalities. First and foremost, it supports multiple formats. What I meant with multiple formats is, apart from dealing with the CSV files, it gives us to access the data of databases, big data files like HDF5 format, Paraquay files, Excel files, text files, and many other. Next, it provides us very unique functionalities of merging and joining data sets, handling missing values, also provides a functionality to give us the access to time series grouping, provides a fast and efficient data manipulation, and on top of it, it provides this all in the very optimized way. And that's why we are discussing it in here, because since it is very optimized, its performance is very optimized, so it comes in very handy when you actually deal with the data sets. Next is Matplotlib. So it is one of the most powerful tools for creating data visualization. You can generate many type of plots like histogram, power spectra, bar charts, error charts, scatter plots, which we are going to discuss one by one. But before that, let's focus like what are the main features. So why we are using Matplotlib instead of any other libraries to start with. So first is, with few lines of code, you can get access to many types of charts that are usually hard to create. Second, low memory consumption. So it does not take much of RAM. So it is very easy to create some useful charts, some useful visual on very heavy data sets. Better runtime behavior. Of course, it's a free service, and so of course, why we not use it? And last is customizability and extendability. So apart from the inbuilt charts it also provides us to create our own customized charts, and so that we can visualize our data in a more enhanced way. Different types of charts. First is simple plot. So it's just a plot between two arrays. Here I have demonstrated that I've plotted graph between voltage and time. It's just simply I have with the time how voltage is changing. Next is histogram plot. So basically histogram plot shows the frequency, it shows the distribution and distribution of numerical data. It's an estimate of the probability distribution of a continuous variable. Next is bar plot. We are going to create all these charts in our Collab notebook separately as well. Bar graph. A bar chart is a graph that represents category of data with rectangular bars. As you can see, these are the rectangular bars with lengths and heights that is proportional to the values. So here are the values which are percentile ranking across second grade boys to the values which they represent against the different features like push-ups, agility, mile run, flexed arm, hang, pacer test. Next is contour plot. Contour plot is one of the most differentiated plot present in the Matplotlib, because it is useful to represent 3D data in a 2D form. So when it comes to machine learning, we are dealing with the high dimensional data, which is not easy to visualize per se. So what contour plot do is, it tries to create some visual out of the 3D data to represent in 2D, so that we for a better understanding. Next is scatter plot. So scatter plot is just the very most useful, or I should say it is the one of the most used plot to visualize the data, which tells this plot tells us the relationship between how two variables, how two features are related to each other. When I say features, features are the part of data sets which makes a data set a data set. Basically, a single feature, what I meant is, I'll explain it in great detail when we'll be dealing with the pandas data frame. So there you can easily understand feature by with the help of a feature, it represents simple a column. Box plot. So it is a graphical method for depicting groups of numerical data through their quartiles. Quartiles are already discussed in this presentation. So with the help of quartiles, we can distribute the data into further segmentation. And of course, box plot is really helpful when it comes to deal with the outliers. Outliers are just the noise data which is present in the data that gives us unuseful results. Next is basic pandas data structure. So data structure, basically pandas provide three of the main data structures to facilitate working with the data. First is series, second is index, and third is data frame. One of the basic series data structure is 1D numpy array. Numpy is already discussed in thorough detail with some but series, what is the difference between series and numpy? Apart from the numpy functionalities, it has its own functionalities of its own. We are going to look at it further. Next is index. So basically index represents each row. What is each row? In here you can see that index is representing what each row represents. Last and most important is data frame. So data frame class builds upon the series class. So series are the 1D numpy arrays, while data frame is 2D or more than 2D numpy arrays. We can think of it as representing like a spreadsheet. Of course, you might have worked with the Excel. So in Excel, we have multiple rows and multiple columns. So in the same way, in data frame, we represent data in the form of a here we have rows and columns. So earlier I said feature. So in data frame, we actually represent each feature with a column. So column 1 is one feature, column 2 is another feature, and similarly we can have n number of features in our data set. And these columns have can have their own data types. What I mean with data types is column 1 can contain the data of integer, column 2 can contain the data related to float, column n can contain some strings, some dictionary, some list, as etc. So the difference between series and data frame is that combination of series makes the data frame. So one series here we can see that a series is so 0, 1, 2, 3. These are the indexes which I was talking about. It is representing that this is the 0th row. 1 is the 1th row, and 2 is the 2th row, and last is 3. And here is the column name is series name is apple. And similarly, we have another series whose column name is orange, and whose indexes are 0, 1, 2, and 3 as well. And after combining these two series, we make a data frame. One important thing to point out here is that this simple summation is done on the basis of index. So 0th index is concatenated with 0 index in orange, 1th index is concatenated with 1, and that makes us gives us the whole data frame in with same number of rows. Read data from a file. We will be looking at some of the most used utilities or functionalities of data frame structure. One of the simple I should say it's the one of these basic or first step is how do we read a data in through pandas. So read CSV. Here I'm trying to read a CSV file called earthquake CSV or earthquake.csv. And PD is simple the pandas object which I am inheriting, which I am importing. It will be more clear when I'll show these things into a collab notebook. And read CSV is the important function that is calling this earthquake CSV. So one important thing, that apart from reading CSV files, of course I have mentioned it earlier that it provides other file, it supports other file formats as well. And apart from taking it the file, so I'm reading this file locally. What I meant is this file is present on my laptop, on my collab locally, which it can access through path, which is root here. But it also provides us to put some external link like HTTP or HTTPS. So if your file is present, if your file has some external link, same as source src present in HTML, you might have dealt with. After reading it, I have opened this data into a object called df. Df represent and if you print df, you will this kind of output will show up where 0, 1, 2, 3, 4 are the indexes representing each row. The topmost column is the header. Contains the column name, and rest is the data which is present in this CSV. So like I said, it supports many file formats. So to read the JSON file, it has the functionality of read JSON instead of read CSV. Similarly, with HTML, it has read HTML. For MX Excel, it has read Excel. With HDF5 format, it has read HDF. With the Paraguay format, it has read Paraguay. With pickle file, it has read pickle. For the databases, especially with SQL or Google BigQuery, it has read SQL or read GBQ formats available. And of course, apart from reading the data, you can write data as well with the help of functionality to JSON, to CSV, to HTML. So these things from the data frame, you can output a CSV file. So basically, suppose you have this data frame present in your memory, in your current code, and you wanted to send it to someone. So of course, you can't send this code, code directly to that person. So what you'll do is you'll firstly output this file into a format which is user understandable, which most commonly used is CSV, comma separated file. And then you can download that CSV and send it to share it further. Now we'll look at some of the basics of Pandas data frame, which comes in handy when we are dealing with the machine learning task specifically. So first is, so after loading the data into a memory, so here I am representing a data frame or data with df object name. So here df will check, we first and foremost check whether the file I have imported, the data I have imported, it is actually present or not. So df.empty, df is simply the data frame, and empty is the utility which is provided by Pandas. It's a Boolean functionality. So it true value represents that our data frame does not contain any data, and false represent that it does have data. So basically it has false here that represents that our data frame is not empty, it has some data in it. Next is to check the shape of data frame. So as I mentioned earlier, that data frame is kind of a data format. It is a tabular data format in which we have certain rows and certain columns. So shape is the functionality to output how many numbers of rows and number of columns are present in the data frame, and that really outputs a result in a tuple. Tuple basically, of course, we have discussed this earlier what tuple is, so I'm not going to explain it on over here. Next is output 5 first rows or user dependent of the data frame. So when you have the data, you of course want to see how your data looks like. So of course, with the few initial rows, you can visualize, you can understand what your data is trying to say. So df.had is the functionality which outputs your first 5 rows of the data frame. So df.head, its output is shown in here, where it has only 1, 2, 3, 4, and 5 rows itself. But apart from that, if you wanted to input output 10 rows, 20 rows, or initial 100 rows, so what you will do is you just pass the numerical digit in here. Here I've passed out 10, so it will output me 10 initial rows. You can pass it 100. If your data set have 100 rows, it will output the first 100 rows of your data frame. And similarly, like we have talked about how to output initial rows, there is a functionality of in the pandas that outputs last rows, last values of the row. So earlier we saw that our data set has a 9332 rows, and whose index starts from 0. So in totality, it has index from 0 to 9331. So df.tail is the facility that outputs the last five rows. So it has 9331, 30, 29, 28, and 27. And similarly, as we passed a number in df.head, tail has the similar functionality. If we can pass, if we wanted to pass 10 or 100, it will output the last 100, last 10 rows. Next functionality is columns present in the data frame. So after importing the data and checking like how many rows, how many columns it has, and you have checked all the data, but how do you output what are the columns, what are the column names in it? So it has a functionality called df.columns. So what it will output is it will output a list, arrays to be specific, which contains all the names of the columns present in your data frame. Next is df.dtypes. So dtypes is data types. If we want to print the data type of each column present in the data frame, so what you'll do is you just simply pass your data frame with dtypes. So what will output is it output your columns, all the columns present in here. The data set has 26 columns presently, and it outputs. So alert is an object, CDI is a float number. If we can check in the data frame, this CDI, it has float value in it, 4.4. Similarly for code, it has integer value. Detail has object. String is considered an object in pandas. Daemon has a float value. So of course we'll look at that daemon has a float 64 value. Similarly, it goes with every column present in the data frame. Getting extra information and finding nulls. So before going to that, I'll like to explain what are null values. So when your data set has no values, for example, this zeroth and alert first, in the first column alert, the first value is nan. So nan is basically representing that this row and this column, of course this cell does not have any value, and it in pandas it is represented as null value. So to check like how many null values are present in the data set, we kind of use a function called df.info, which outputs the how much memory our current data frame. So of course, if your data size is big, your memory usage eventually be going to be large. So it contains all the information related to data frame, its data types, how many types of data types is present in the data frame, what are the columns, and what are the non-null counts. So it has 95 non-null counts. So the column has only 59 values, and rest of the rest of the values in that particular column is null, is not given. Next is get summary statistics by .describe functionality. So describe basically tells you about mostly about statistics part, like mean, standard deviation, minimum, maximum range, quartiles, different quartiles like 25% at 50% and 75%. And for each column, it is given separately. Next is for selection of columns. So when you are trying, when you're dealing with the data, there come many chances that you wanted to access one particular column to see or to do operations on it. So how will you access a particular column? So there are two methods. One is the dot method, and second is the bracket method with the name of that particular column. So df is our default data frame and mag is the column name. In here we have discussed that all the column names can be shown by this df dot columns. From here, this mag is the column name and we are outputting that particular column with the help of df dot mag. And second method is df braces brackets, and in that, in inverted commas, just mention the name of the column, and it is outputting just single column. You can check that it is, of course we are outputting only single column, so it is giving us a result in a series instead of a data frame. So what we learned earlier is ki series are one dimensional structure. So here only since one column is present, it is of course outputting the results in 1D. But when we are selecting multiple columns, so what to select multiple columns, what we'll do is we pass a list, we'll pass list of all the columns in inverted commas within the data frame, and it will output all the columns in here. Next is slicing. Slicing is one of the most important tool, I would say, present in the pandas. So like matrix, say its function is similar to like matrix. So in matrix we have df 01 to access the zeroth column element with zeroth row element with one column. Similarly, selection of rows can be done by slicing using number. So here df, and we have the brackets, and I'm passing 100 colon to 103. So what is the 100 is representing is the index number. So through index number, I am calling those three particular rows. So from 100, it is 100, 101, 102. Point to be noted in here is that 100 is inclusive, but 103 is exclusive of it, because the indexing starts in pandas, indexing starts from 0, and it is one number always less. That's why 103 is always exclusive, while 100 is inclusive of the index number present in the data frame. So here 100, 101 and 102. Next is to select. So here we have selected only 3 rows from index 100 to 102. What if we wanted to select specific columns as well? So we can of course select simply by slicing, simple slicing as this. We will select df with the, of course we have seen the structure df title dot time represent only these 2 columns, right? So we'll just concatenating both of the syntax together. So first is columns, and then is we are selecting rows. So first it will select the columns. Both columns are got selected, title and time, and then out of all the rows, it will select only rows with index 100 to 102 index. Or you can reverse the order. So it will in the second syntax in here, what it is telling is that first it is selecting the rows from 100 and from index 100 to 102, and then it is applying operation on columns to select that particular columns mentioned by the user. Next functionality is indexing. So indexing is one of again is it's slicing and indexing, one of the most important tool present in the pandas library. So if we want to update a particular value, so we know how to select rows and columns now, how to select each cell. In fact, we know that now. So how do we update the values given that we have selected that particular row and column? So if we try using that, what we have learned is that, of course, we are selecting the rows from index 110 to 103, and then that particular column, I'm updating that all those values should be converted to lower. So .str represent that I'm accessing all the strings present in the data frame, and .lower functionality is representing that all the values which are present, all the text, all these strings which are present in here, it should get lowered. Better way of use, of course you can use this functionality, but Pandas will give you a warning that these operations are directly performed on the actual data set and not a copy of it. So whenever we try to manipulate the data, we don't directly deal with the original data. We try to create a copy and then do all the operations on it. In case if we so if in case we need the original data, we might data, and from that we actually use the copy of that data set. So better way is to use lock functionality. Lock represent location. So df.lock is representing, and it works on columns only. So rows, of course, you can handle with 110 to 112, and by putting comma, you can give the title. Title is the column name, and you are accessing this title with the help of a .lock function. And of course, this rest of the syntax remains same, that df.lock, it is lowering the string values to get updated. And if we'll update, it will see. Yeah, next is location indexing with lock. So how do we so earlier we saw that to output one particular column, there are two syntaxes, df.mag and df bracket mag, given the column name. And there is another way that we can do it, is df.lock. So lock is basically accessing the columns, and here df.lock is already been explained. Column is representing all the rows, that this data frame should select all the rows present in the data, and apart from and then it is accessing title. So after selecting all the rows, it should output only title column, as you can see here in the output. Apart from this, we can use lock to select specific rows and columns without chaining. So same function as we have done in here, df, where we have output rows from 100 index to 102 with certain columns, only with certain columns. That functionality can also be implemented using that lock function. So basically lock is applied only on the column part. Next is integer location indexing with ilock. Now ilock work when we want to deal with columns as integer. So in a data set, this is the till now we were dealing with the column names, alert, CDI. We were passing a column name every time we wanted to access particular column. So it also provides a function. Pandas also provides a functionality in which where we can deal with the columns in a numerical form. So alert is the 0th column, CDI is the 1st column, code is the 2nd, detail is the 3rd, and so on. So in order to access columns in such a way, there is a functionality called df.ilock, in which rows, of course, rows will remain, the syntax to access rows will remain same, only it is experimenting on the column side, where 19th and 8th. So I'm telling df.ilock to select rows from 10 to 15 index and select 19th and 8th column. Here I'm passing a list in which I have mentioned that it should select 19th column and 8th column, which are title and mag. So so earlier we have accessed those two columns with the help of column name. Similarly, we can use slicing index with ilock for both rows and columns. So suppose we want to, so like we have in ilock functionality, specifically in row, we were telling that it should access from index 10th to 15th. Now same functionality, this column functionality can also be applied to columns. How? We can see in the next example that df.ilock, it contains same 10 to 15 index number rows, and I want to display all the columns from number 8th to number 10th. So 8, 9, 10. So basically, of course I told you earlier that last index is not actually counted because the indexing actually happens from the 0 in Pandas. So eighth column is mag and ninth column is mag type, and of course the rows remain same, that 10, 11, 12, 13 and 14. Next is data visualization box. We're going to look at multiple type of plots in the next section. So starting with the basics, so what we want to, so of course everybody is familiar with the Cartesian graph in here, that in which we have coordinate axis x and y, and we point certain points on the graph, and we try to match the line. Here I'm doing the same thing with the help of a matplotlib library. So here what I'm trying is, I have the list 1, 2. So here I have one list 1, 2, 3, 4, and next is 6, 7, 8, 9. So what I'm trying to do is I am importing first matplotlib object as represent that I don't want to use this functionality directly, so I'm giving it as an alternative name, PLT. So PLT represents the matplotlib library itself. And similarly, I'm importing NumPy library as NP. So as represent that NP is inferencing to NumPy. PLT is the again matplotlib object. Plot is the functionality of matplotlib from which we are going to actually plot the data. So array 1, 2, 3, 4 are the points against 6, 7, 8, 9. So you can see that 1 is matched with 6, 2 is matched with 7, 3 is matched with 8, and 4th with 9. So these are 1, 6 xy coordinates, 2, 7 xy coordinates, 3, 8 and 4, 9. So here is the 1th point. Then we have 2 and 7. So 2 and somewhere here 7. And then 3 and 8. Of course, 3 and 8 in here. And last is 4 to 9. So 4 and 9. We can also enhance this plot by inputting some labels. So we don't know what these values are and what are these values. So we can provide name, we can put the title, what each value is representing. We'll see in the next slide. So adding labels and title. So of course, we know how to plot a graph now. Next is what is x-axis representing. So we'll give a label by a function called xLabel. So PLT is again the matplotlib object, and xLabel is the functionality through which we are going to label this axis. So I have given the name as x-axis for the simplicity, and y-axis as y-label. Then I have also put the title. Title of the plot is that I have drawn the first plot of matplotlib. And PLT, I forgot to mention about PLT.show, that PLT, of course, you have created the graph, but how will you actually see this graph? So PLT.show will help you to actually see the graph in your notebook or in your Python IDE. So PLT.show will actually output all the things we have done till here in by running this code, it will output all the things you have done earlier. Next is it's just in style format that we can pass a string specifying the style of the plot. So here I am so earlier I have used the line. Here I'm using the dot. So dot is being represented by go. And similarly, I can use a dash with the help of a k minus minus. So these are different type of styling that I'm trying to use. So what I'm trying to say is, apart from just simply plotting the graph, matplotlib also provides us functionality to visualize it in different type of styles. We can make a black dash line, we can make a red dots, green dots, etc. Next is suppose okay, so this is, we can plot multiple sets of data by passing in multiple sets. So till now I was plotting only one array against another. What happens if I have this these xy coordinates and these xy coordinates. So so in this graph, we are trying to plot both of these graphs into the same graphs. So how matplotlib do is, these are this np is the numpy function, arrange is the utility which gives us a list of 1 2 3 4 5, and y is x exponentially 3. So is a cube. X is, it's in the exponent 3. So every value of x gets multiplied by 3 itself. So 1 cube is 1, 2 cube is 8, 3 cube is 18, sorry 27, and so on. Next is of course this is the x and y. We know how to plot this syntax is familiar with you, that we are plotting this array with this with the help of go. So go is representing the green dots, and and to go further, we are passing these xy, these coordinates as well, but I'm trying to differentiate it with the help of styling. So I'm passing it with the help of r and this sign. So it gets converted into these triangle forms, and everything remains the same, that x label, y label, plt dot title and plt dot show. Next is that we want to create two subplots within the one graph. So we'll try to use the functionality called subgraph. In here we have to pass 1 2 1, and this is the simple syntax that we plot, and we are passing the numbers or the data which we are trying to plot, and plt dot title. So here I wanted to clarify that this plt title is only for this subplot. We can also put the whole title, like you can see in two plots in one figure in here, with the help of a plt dot supertitle subtitle. Two plots in one figure. This is our main title, and first plot is the subtitle, and similarly with the next subtitle we have second plot. And again last is the, after plotting all the things, all the xy coordinates, I am just showing the output. Next is, so in here I have represented those graph vertically. What if I want to represent those graph in a landscape form? So what happens is we have to change these numbering. So earlier it was 1 2 1, and in here it is 2 1 1, and similarly within here in the second plot it was 1 2 2, and now it is 2 1 2. So here I'm trying to explain how you can so these were the simple data set I have took. These are the only the simple arrays. So how we can visualize the actual data when you are actually importing some file, some data into your Python IDE through Pandas or any other library that you want to use. So how you can actually visualize your data. So here I'm using FB, Facebook stock data from 2018, where date is the, so earlier we saw that we have index 0 1 2 3. From there it has index from date, so each date is the column. So this row represents the data of this date, this row represents the data of this date, and we have 5 columns in here: open, high, low, close, and volume. So opening price of a stock, high, how much high and low, and of course at what price the stock got closed for a day. So first is a line plot to show the relationship between a particular date and its stock price. So plt, again it's a matplotlib function, and dot plot from where we are actually plotting this line graph, and what we are trying to plot is fb dot index. Fb dot index is the date. I told you that I here in this data set index is not 0 1 2 3 but actually the date. So fb dot index is the date, and fb dot open is the opening price of that particular stock. So we can see how the data is varying, how the opening price is varying on a particular date. Next is scatter plot to show the difference, to show the relationship between high and low price. So we are plotting against a high price and low price, and with the help of a arrow, we are specifying the styling, what kind of styling that we want to do. So here I have put it as dots, round dots. And okay, instead of using whole data, I'm specifying that it should use FB is the data object. So earlier it was DF, right? I have given it different name called FB, and we have already seen what head does. So head, it outputs the initial row number, and how many rows it will output, only 20 initial 20 rows in from here. Next is to show any distribution. So of course we have discussed like what histograms do. Here I am querying quakes is the column, quakes is the data set, and I'm querying that data set to output a particular column, and in that particular column I want only the distribution of this particular value. So map type is a column in which it has certain kind of categorical values, and I am representing a plot. I'm trying to visualize a plot, seeing the distribution of how ML changes with the frequency. So you can see it's kind of a normal distribution, but not exactly. So in the next plot with bin size, we are using the bin size. So we can see here we have taken bin parameter as 7, and in here parameter bin sizes. So what basically bin does is it divides your data into certain groups. So here I have taken a parameter 7. So the data has been divided into 7 categories, and in here I have taken bin parameter as 35. So the data has been divided into 35 groups. So we can change, we can see, we can notice how our assumptions of the data distribution is of the data can change based on the number of bins. We can use this histogram to actually represent most real life scenarios where our norma is actually not normal. Next is box plot. So with the help of a box plot, we are trying to see the distribution of magnitude across different measurements methods of earthquake. As already discussed, that box plots are the standardized way of displaying the distribution data based on a 5-number summary. First is minimum, first quartile, median, third quartile, which is 75%, and its maximum. So basically it is trying to distribute all the features. Features is open, high, low, and close on these 5 number summary. So what we are trying is that so basically what it gives us the idea, like how our data is being grouped together. And a box plot is also helpful in determining any outliers, as discussed earlier. Before going to a hands-on session machine learning, let's take a quick 30-second break, and then we'll be moving forward from here. Okay, I was some of the questions that why slicing is important. So somebody has asked why slicing is important. So best way to answer is ki, well, actually you are dealing with the data, it will come in handy. So like I'll discuss it in further great detail. So for show you an example, here I'm trying to load a data set, and only I'm trying to load certain values, certain columns with all the row numbers. So in here the slicing comes handy when you're not trying to load all the data, and you're just, so when you're when you see that data, which we am talking about is very big on a very large scale, which is very hard to deal and hard to visualize and hard to work with. So what we do is we kind of take a subset of the data according to a and we decided it's a user decided that whether he wants a small data set or big data set, and he tries to visualize that data, because much of the larger data, it can make the visualization very complex, which is hard to understand for us as a human. Next is hands-on session machine learning with Scikit-Learn. So first we'll see the theory part of some of the machine learning algorithms mostly used and most common to start with your machine learning course, and then we'll come to the code part. So which library I'm using to work with is Scikit-Learn. So Scikit-Learn is the most useful library for a machine learning. Why? Because it contains a lot of efficient tools for ML and statistical modeling as well. Some of the key areas are, so basically it provides simple and efficient tool. So to build an algorithm, we have to write a lot of code. It can be 1,000 and 2,000 and 3,000 of lines. So instead of dealing those those time-consuming tasks, Scikit-Learn already made efficient list of algorithms to have and make it public to have the access. So everybody, first accessible to everybody and reusable in various contexts. And why it is very fast? Because it has built on NumPy. NumPy is most of the fastest data structure we have. SciPy and of course Scikit-Learn, it comes in handy with the Pandas and Matplotlib. So it is very easy to visualize the data with the help of a Scikit-Learn. So when you will actually represent the data, instead of directly inputting into a Matplotlib particular format, you can actually plot a data frame itself. We'll see how we do these things. And last and foremost, is an open source commercially usable library, so anybody can use it. Some of the main features features or key areas of ML in which Scikit-Learn do wonders are feature pre-processing, model selection, feature selection, hyperparameter tuning. I'll discuss each term in detail now. That what is feature pre-processing? So when you have data, you have certain features. Some of the features may not be in the form that you wanted. So you had null values, but your algorithms cannot create null values. So what you have to do is you have to pre-process your data, remove all your replace your null values with certain kind of values that you want. It can be mean, median, or mode. I'm not going into much further detail, but yeah, next is model selection. So model selection is what kind of algorithm you want to use and where. So it tells us that as well. Third is feature selection. So in a data set, you suppose you have 100 columns. So how you decide that which feature, which column is the most important to predict something? So it tells you, it provides the algorithm for that as well. Last is hyperparameter tuning. So hyperparameter tuning is somewhat related to algorithms. It's a deeper term in its whole. So hyperparameters. So uh, parameters are the values or variables which goes into a algorithm which user provides, or algorithm has its own default value. So and based on that particular variable value, your output differs. So how do we exactly get those values so that our model, our algorithm outputs the best results? So that process, like how we are determining what parameters to set to get the algorithm work in a most efficient way, most best way. So that is done by a hyperparameter tuning. And of course, the algorithms are available for it in Scikit-Learn as well. So algorithms present in the Scikit-Learn are some of the classification tasks. So classification task is basically identifying which data data point belongs to which category. Next is regression. So regression is, I'm going to discuss each and every algorithm in great detail further. Regression is predicting a continuous valued attribute associated with an object. For example, we want to predict that for a certain person, it has this position that it works as a data scientist. So what is its salary? The salary is the salary is the continuous variable. It's not a discrete value, where classification has discrete values in the form of either 0 or either 1. Next is clustering. Clustering is automatic grouping of similar objects into sets, like customer segmentation, yeah, grouping experiment outcomes. Next is dimensionality reduction. So dimensionality reduction is the area where we are dealing with the big data, and to deal with the big data, we require lots of resources, high RAM, high computation power, high memory usage. So what we do is we try to reduce the size of the features which which our model, our algorithm is using to predict certain results. And how we are going to do that, we'll discuss in the next part of the slides. Next is model selection. I have already covered this point. Like, there are many algorithms in the data science, but what to use and when to use, it also tells you with the help of a parameter tuning and pre-processing as well. Now, for this section, I'm going to discuss regression algorithms, classification, clustering algorithms, talk on dimensionality reduction, and some performance metrics through which we can determine how well our ML model or machine learning model is performing. To start with, what is regression? So to put simply, regression determines the relationship between two or more than two variables, how they are related. So it's a basically simple statistical method that determines the strength and character of the relationship between one dependent variable and a series of other variables known as independent variables. So in regression problems, we often have a similar situation as in which we have one dependent variable which we are trying to predict, and others are independent variable through which we are trying to predict that dependent variable. Here you can see that basically this is the linear data set, and this is the line which are segregating these two types of data. This is also linear, but this is non-linear. We are going to discuss like what is linear and non-linear type of regressions in further slides. So what types of regression? So basically, first is linear regression, second is logistic regression, third is rich, fourth is lasso, and last is polynomial regression. So linear regression means that to put it simply, we are trying to find out this red line that can best fit into the data so that we can predict the values in a best way. So we know that the key idea is to predict a line that best fits the data. Means, so each and every line, the equation of line is y equals to mx plus c, which is representing this line. Here m is the slope. So slope is the per unit change with the value of x-axis. So here, for an example purpose, I have taken size of houses. I have a graph. I have some data points representing how the prices are varying according with respect to the size of houses. So each data point represents that at this particular size of house, the price are considered as this. So here, this is our slope and C is the intercept. So intercept is the line which is cutting the y-axis. So in linear regression, we are trying to find out this line. But how we are going to find this line, we're going to look at in the next slides. for that, so what we are trying is why we are, so first of all, what question comes that why we are trying to find out this line, what we are trying to achieve from this. So this is the data set we have, but I wanted to predict that at this point, at this particular, let me change the marker color. Yeah, at this particular point, at particular size of the house, what is the price, and how we are going to predict is through this line. So how we are going to predict it? So here was the point which was I was talking earlier. I'll make so if we don't have this line, we cannot of course calculate it the price corresponding to this house, size of the house. But this line of course best fits the data. But question comes like there can be many lines from which you can predict the price of the house. Then again the question arises that what is the best fit line then? So best fit line is the line which minimizes the distance between the line and the data points. So this is the line and this is the distance between the data points. These are the data points, of course, and this is the distance. And summation in a such a way, of course, we are trying to find out a line that can minimize this distance as much as possible, so that our error, the final error we are getting at the end, should be minimum. For that, we try to define a cost function. So how we are going to minimize it, I have detailed out in here that we have a cost functions which we are trying to minimize. So h theta of x, so h theta is basically equals to y equals to mx plus c. You can represent that theta 0 is the intercept, theta 1 is the m, and x is our feature, and y what we are trying to predict, y hat in, if I say so. Theta and theta 0 are the parameters which are trying to predict. And how we can predict it? With the help of a cost function. So what I'm trying to say is that we are trying to minimize this cost function. And what this cost function is representing, it is representing the distance between the line, that particular line which that particular cost function is considering, and the distance between those points from the line, and for the line for which we get the least error, the minimum error. So what our goal is to minimize the error so that we get the best fit line. So for the line which we have the minimum error is considered as a best fit line. Here is the code which I'm going to run separately in the collab, but just to give an overview, here I'm importing matplotlib, of course you are familiar with it, numpy library, and the new term comes as here that Skillup. So here I'm importing some pre-built inbuilt data set and linear model. So linear regression is the linear model where variables are varying in a linear fashion. Some of the matrix, I'll discuss this detail further, discuss this point further in next slides. And I'm trying to load the diabetes data set. So I have a data set which talks about the diabetes, and what I'm loading the data set which have X. So diabetes X is representing generally in machine learning, we try to represent the feature set as X, where X1, X2, and so on are the columns, or I say features, and Y is the target variable. In here, target variable in linear regression, in here it is a continuous variable which you are trying to predict with the help of these features. I'll show you how this data set looks in Collab, just for the understanding that I have the data set which I'm going to train. And so of course I have divided the data into a training and testing sets. So as Krishna sir has already discussed, that when we are trying to deal with the data, when we're trying to predict when we're doing something in machine learning with the data, our main goal is that apart from the data we have, machine learning model or any AI task should perform good on unknown data which that model has never seen. So that's why we have, that's the main reason that we divide the data, our data set, into two parts. First is training set, on which our model is going to train, and the testing set, on which we are going to test like how our model is performing on the unseen data set. And then I'm just so basically this is the features data set, and this is the features of a test data set. Similarly, this is the y, of course, the variable, dependent variable that we are trying to predict, and this is the test data, test target. Next is we are creating a linear object regression. So in particular, creating this whole mathematics might take you a long time. This is the linear regression. So it has, I have discussed with only one parameters where theta 0 and theta 1, but it can have multiple features. I've only talked about that your linear regression should contain only one feature, but there are many cases where you see that you have multiple 10, 100, 1,000 number of features. So that this can be represented by this formula, where y is the dependent variable, beta 0 is the intercept we talked about, c, beta 1 and xi is the feature set, x1, x2, x3, and beta 1 and is the m, here slope. So eventually we are trying to predict beta 0 and beta 1. So a line is represented by its slope and its intercept only. So our end goal is to predict these variables. And here is the random error. So this random error is important in here. It's because when we say that our data is linear, we kind of, it's not always true, or our data, so in an ideal world our data should be linear, but when we come when we deal with the real data set, real world data sets, it's not always true. That's why we have this random error term, which is normally distributed to the data set. So as shown earlier in a picture, that we have the data and we are trying to predict this baseline. I'll show you the data and how everything is working in the Collab notebook. Next is logistic regression. So logistic in linear it is a kind of a linear regression model, with the change that our linear regression was outputting continuous values in the form of 0, 0, 0.1, 0.2, 0.3 till 1. But in logistic regression, it categorized the data into two categories, either 0 or 1. So how we are so basically your output of the linear regression basically is going to of continuous variable is going to convert into different categories based on some threshold or some criteria that we are going to use. So our basically data set was, earlier in linear regression, we were trying to find out this baseline and this, this baseline, this one. This is this baseline, and how it has the continuous value because we are trying to find the line. But now we are trying to differentiate the data between these type of data. We are trying to make the categories of this and this data. So how we are trying to do is with the help of a complex cost function called sigmoid function. What sigmoid does is it maps any real value. So real values are our values from the linear regression part, and it converts those values into another value between either zero or one, or either any categories. I am just, for the example purpose, I'm saying that it is category 0 or category 1. In ML, we use sigmoid function generally to map prediction to the probability. So we had the prediction and I'm just mapping those predictions to make the probabilities. Sx equals to 1 upon 1 e minus x is the sigmoid function from which we are trying to convert the continuous output into a sigmoid output in a zero form output. So initially, mathematically speaking, we had y equals to mx plus c, and our y was varying between 0, 0.1, 0.2, 0.35, 0.99 values. But now the hypothesis of logistic function is that it tries to limit the cost function either 0 or 1. So what we are doing is h theta of x is y. So we are out just applying that sigmoid function which we have seen earlier. Here x, we are going to replace this x with the actual y hat that we have predicted. So this was the line which we are trying to predict. We'll replace this in here. So you can see that we have applied this sigmoid function on the y while just simply writing it. And in here, I'm actually trying, this x is actually replaced by this line, this predicted line. So h theta x equals to 1 upon 1 plus e to the power minus beta 0, b0, it is the intercept, and beta 1 x. So this formula is for only, so x here is the set of features again. Here x is the again set of features, beta 0 is the intercept, and beta 1 is the slope that for the given best fit line. And h theta is the y which we are trying to predict. For cost function, now earlier we've seen that in linear regression, the cost function was to minimize this distance from the line. Now we have categories. So how the cost function changes is we have again the log of h theta of x. So the cost function changes in such a way that log of x, that it is log of h theta of x if your category is 1, and minus log of 1 minus h theta of x if y equals to 0. To simply combine, the whole cost function is minus 1 upon m, where m is the number of data points present in your training data, in your total data set, into into the summation of all the data points, yi into log of h theta of xi plus 1 minus yi into log of 1 minus h theta. So this is the predicted value. This was the actual value. In here, h theta x is the predicted value, and yi is the already present or actual value. To show you an example, so for the logistic regression, here the NumPy matplotlib, here I've imported Skillup.linear model logistic regression, and by importing I have imported a iris dataset which basically contains the information about plants and its features, like how a particular plant has its features to categorize with. So for the easy computation, I have taken only first two features, basically first two columns, and I have the target. I'll show you the this code in Collab. There you will understand like what kind of categories we have there. And I'm simply fitting, this fit function. You'll see, like once you have made the object of an algorithm that you want to use, after that you just have to fit your data, where x is the features from which you want to predict, and y is the variable that you are trying to predict. Next is ridge regression. So before going directly into a ridge regression, there are some terms that I would like to discuss. First is bias, and second is variance. So in ML, you'll encounter with these two terms very often. So what is bias? So bias is the basically difference between the average prediction of our model and the correct value which we are trying to predict. So it is the average prediction of a model and correct value which we're trying to predict. So model with high bias has very little attention to the training data, and it generalizes, oversimplifies our model. It is always lead to high error on training data and test data. So when we say we have a bias is present in our model, what we're trying to say is that model does not, our built model like linear regression is a model, Logistic regression is a model, is a ML model. So these model have paid very little attention to the training data. It does not understand. It does not understand that pattern very well, and it just simplified the model. Basically, it created very simple pattern out of the data, and it which leads to. So what happens is when your model pays very little attention, it understands your data very less. So what happens is when it comes to the unseen data, of course your it won't be able to predict your test data as good as possible. So here when we say that when so according so bias basically is the difference of the average prediction of model and the correct value which we are trying to predict, whereas variance is the variability of model prediction for a given data set or point or a value which tells us that spread of our data. So model with high variance pays a lot of attention to our training data but does not generalizes on the data which we haven't seen before. So to differentiate between two, bias is not paying attention to our training data, and it is giving error on our training data and testing data as well. But variance, on the other hand, pays too much attention. It learns the pattern in so hard, it's so much that when it comes to the unseen data, it fails there. As a result, such model does not perform. Of course, these types. So variance, when we have high variance, sorry. So these type of models in which your variance pays a model with high variance, basically. So these models perform very well on trainer. It will give you 100% accuracy that your model is trying to predict 100% the target variable. And of course, you think that, yes, I have trained the model very well. But when you see on the testing data, on the unseen data, you'll realize that it gives you high error because your data has learned the structure, the pattern of a model very well, so well that it cannot even uh, trying to generalize that pattern over your unseen data. So this generates the concepts of overfitting. So what overfitting does is, suppose we have the training data, we have 4 points, 1, 2, 3, 4, and this is the best line. So earlier what we were trying to do was, this was the cost function earlier, which we are trying to minimize. But now you can see that that particular data points are this best fit line is passing through all the data points. So this means this error should be 0. Of course it should be 0, right? Now, yeah. So what happens is, in this scenario, what happens is in this scenario, when your testing data, of course this is the testing data, what which I'm trying to talk about, is the unseen data which your data hasn't seen, your model has not seen before. So what happens is it will create a huge difference between the best fit line and test data, and eventually your error will not become 0. Hence, this terms where your your model is performing too well on your training data but fails to understand your test data, results in overfitting. So overfitting means that for particular training data set, you have a low bias result, but for training data set, it gives high error. So in linear regression, we have the cost function as sum of squared errors, which is same to sum up in some two words. It is sum of squared errors. Of course, it is the error. Y is the actual value, and y hat is the value which we are trying to predict from y equals to mx plus c. And to make the square, and of course we are summing up it on all the number of data points. Hence, what we are trying to convert is, Yeah, sorry. So what we're trying, so of course our model has overfitting, which means our training data set gives low bias result, but for the training data set, it gives you high error. So what we are trying to convert is through ridge regression, what we are trying to convert this high variance into low variance. So that's where ridge regression and lasso regression, specifically these two techniques comes into picture. And just to specify a point, a good and generalized machine learning model should have low bias and low variance. And of course, you can see that the spread of this data set, this testing data, this is too high for the model to get generalized. Next is, so we have seen that linear regression is the sum of squared errors, which is, of course, I've shown you that 1/2m y minus y hat whole square, right? What ridge regression does is, apart from minimizing this sum of squared error, it has an extra term. We are going to discuss this term in detail, that why the effect of this term is important. It has lambda into the slope. Basically, slope is this. For a unit change, the slope of this line, this angle which we are talking about, slope of this square. So as the value of lambda increases, the line gets horizontal and slope of reduces in the, so I'll show you like how this whole idea works. So suppose we want to calculate the cost function with the help of this cost function now, ridge regression. With the help of this, instead of we were calculating the cost function through this in linear regression and logistic regression, but now we're trying to calculate the cost function with the help of a ridge regression. So what difference does it make? So a ridge regression is the minimum sum of squared error plus lambda into slope of square. So since your training data is trained too well on your so your training data is trained too well, so of course this sum of squared error should be 0, as we have seen earlier. Therefore we are only left with lambda into square term. So for in this particular case, like the slope in this particular is high because of the steepness. So basically what we are trying to do is, we are trying to reduce this line to make it like that, so that it gives you a less error. So how ridge regression is helping us in doing so, by reducing this angle to this angle. So for a particular situation, let us consider that we are picking some lambda value in between 0 to 5. We are picking some values let's say 0 to 1, and let's say 1 for easier calculation, so that we can calculate. Now since the slope is very steep, you know that this line has m value is the m value is very high for this line. So let us take that slope is 1.3. Now therefore error becomes, so while calculate, so we'll calculate, so lambda into slope square. So lambda is our 1, cross square is 1.3 square, which is 1.69. So our whole error becomes 1.69. So the important point to note here is that when your error becomes 0, your model should stop working. Your algorithm should put to stop to calculate further. But now you can see that your error is not 0. So what model will do is, it will calculate further. It will consider this line now as the next predicted line, as the next best fit line, and then it will calculate again the distance and check whether you have certain reduced errors. So suppose in this line, this we have less slope. So I take 1. So 1 into 1, 1 is the lambda, and again I'm taking the slope 1 here. So 1 square, so which results in 1. So 1.69 was the earlier error. Now we are getting 1, which is less than that. So, and again, the model will try to learn. So actually what we are trying to do is we are actually reducing the slope or this steepness, so that our model can generalize this test data as well. This slope can never goes to close to zero, because of course it has a reasoning for it, because we are multiplying with the slope square. We are multiplying with the slope of the square, and that's why this term can never become zero, exactly zero. It can become it can come up to the close to zero, but it can never be zero eventually. So basically, ridge regression means a variation of linear regression. The key idea behind ridge regression is to find a new light that doesn't fit the training data as well. So we introduce a small bias. So lambda into slope square is the bias we introduced from our side, so that our variance drops significantly, but our performance of the model on the unseen data becomes better. It uses L2 regularization method. So this lambda into slope square is the L2 regularization that is used to get rid of overfitting. Here is the simple syntax of ridge, how we can import from scikit-learn. So there is this function called there is this class called ridge, and you can fit your data like x train and y train as we have done earlier. Next is lasso regression. So the functionality of lasso and ridge is totally similar, with the difference that in lasso, in ridge we have L2 regularization, but lasso had make use of L1 norm. So what? So here we had in ridge, of course, this is the sum of squared error, this term, and instead of in ridge regression we had lambda is the parameter, and in here we had the slope of square, but in lasso we have the magnitude of slope instead of slope square. So what actually difference does that make? So it not only helps us in overcoming the overfitting, but also help us to do the feature selection, because we are considering magnitude here, so there is a great chance that many of the, so beta j is representing that beta 1 plus beta 2 plus beta 3 for multiple features. You have the equation m1 beta 1 beta 1 x1 beta 2 x2 plus beta 3 x3. So your over all magnitude becomes lambda of m1 plus m2 plus m3, or in some cases as lasso work, it can become zero and remove these features, hence segregating the unimportant feature. So how lasso is better, we can say is that it can shrink the importance. So there we had lambda into slope square, which can never become zero, and it can only come overcome overfitting. But lasso, on the other hand, apart from overcome the overfitting, it also gives us how it also provide us a facility through that we can segregate our unimportant features, or we can say it has the functionality to feature selection. Polynomial regression. So polynomial regression is basically is used when you have nonlinear data. So what happens when you what happens if we know that our data is correlated in the correlated, but you know that relationship is not linear in the sense that you know that one variable varies with the other, so it either increases or decreases. But what happens when it is not the case? It is suppose a scenario which I'm trying to give you is where uh, I'm considering two variables, and with the respect of that x1 variable, x2 first increases and then decreases, uh, similarly like this graph. So we do, in this case, we do polynomial regression on the data to fit a polynomial equation, so that we can minimize our same cost function. So what are the steps? So of course, just it has the so what we earlier doing was data, and we had the data and we were applying linear regression and we were getting the predictions. But in polynomial regression, we have one extra step is to convert those polynomial features, those non-linear features into a linear feature, and then we can apply linear regression. It is a two-step process. What is the advantage of polynomial regression? That it provides best approximation of the relationship between the dependent and independent variable. So it not only applies on the, it tries to cover all types of relationship instead of only linear kind of relationship. Hence gives us the wide range of functions and curvature to work on. Here is the feature that as Scikit-Learn provides. So here is the class called polynomial features. It has the degree 2. So basically is theta 0 plus theta 1 x1 plus theta 2 x square. It works in that form. So degree 2 represent this equation, that y equals to theta 0 plus theta 1 x1 plus theta 2 x1 square. And after converting those polynomial features into linear form, we are actually passing it to the same linear model to fit the data. Next section is classification. So regression, of course, we have covered one algorithm of classification, which is called logistic regression. But and classification basically is the segregating the data into different categories, like class A, class here we are representing class A and class B. So a machine learning task that deals with the identifying the class to which an instance belong, and that is called classification. Most commonly used classification algorithms are logistic regression, k-nearest neighbor, decision trees, support vectors, and naive Bayes. We are going to discuss 4 types of classification today. First is binary, second is multi-class, third is multi-label, and fourth is imbalanced dataset. Binary classification refers to the classification that has the data which have only 2 categories, either 0 or either 1. So most of famous examples are email spam. So in your Gmail, you get you have a special folder called spam, and your Gmail, of course, the algorithm behind it automatically detects whether your mail is a spam or not. Similarly, churn prediction. Churn basically tells like which customers are most likely to use a certain kind of service or not. And third is conversion prediction. So what kind of people, or which are the most which people are most likely to buy certain kind of things. These kind of examples are included in binary classification. Multi-class classification refers to the classification tasks that have more than 2 class labels. For example, phase classification, plant species, and third is optical character recognition. So basically, you have class 1, class 2, binary class, and class 3. So there is so algorithms for the multi-class remains the same. That is logistic, linear, logistic, k-nearest, etc. But method of using it becomes different. So there are 2 types of types in which we can use those similar algorithms. One is one versus rest, how we actually trying to train that specific data. For example, multi-class classification deals with red, blue. For example, for a multi-class classification, we have classes red, blue, and green. And this could be divided into 3 binary classification data set. So binary classification becomes problem number 1, red versus blue and green. Second is blue versus red and green. And third is green versus red and blue. So with the help of these 3 problems, we are trying to predict those multi-class classification. And another one is 1 versus 1. So in this, we are trying to fit the model red versus blue, red versus green, like each color with each individual. So we are making all the possible combinations: red versus blue, red versus green, red versus yellow, blue versus green, blue versus yellow, and green versus yellow. Last is third is multi-label classification. So multi-label classification, it requires to predict multiple mutually non-exclusive classes. So instead of assigning only one label, it assigns a set of labels. For example, a user, for example, this is a user and these are the set of items. So what all the items user can buy? So user can buy grapes, orange, pomegranate, apple, pineapple, strawberry, etc. So in this we have multiple target class instead. So it can have so for a particular data point we had earlier 0 and 1, but in this case we have 0, 1, 2, 3 and many more. Imbalance classification. So imbalance classification is the classification where is the number of example in each class is unequally distributed, and which leads to some model defaultness. For example, these kind of example includes fraud detection. So fraud detection is basically number of fraud is very less as compared to fraudulent users. Outlier detection, of course, the noise that we talked about. Third is medical diagnostic tests. Next topic is clustering. So basically, clustering is a technique for finding groups of objects such that the object in a group will be similar to one another and different from two rest of the groups. So one of the most common and simple used clustering is k-means. K-means is one of the simplest clustering unsupervised algorithm. So it identifies k number of centroids and then allocates every data point to the nearest cluster, while keeping the centroids as small as possible. So it starts with taking these data points. So here k means k is the number of centroids which user has to give, and then it identified, then it allocates each and every. So here we have 1, 2, 3, 4 centroids, and it tries to calculate the distance between this centroid and each and every data point associated with it except for the centroids, and then it considers which has the closest distance. It keeps those data points in its cluster. So for the first function, what we are trying to do is we are actually minimizing this distance between this centroid and all other data points. So basically here summation of k equals to capital K, basically minimizing the sum of square distance to its representative object in each cluster. So representative object is the centroid which we have picked, and we are trying to minimize that distance in every cluster. So suppose I have picked 4 cluster in like as shown is the example. So the algorithm will run 4 times to minimize the distance between that specific centroid and the data points. Here is the example like how we can actually use k-means from Skillup. Here is the, of course, the cluster is the class and k-means is the actual algorithm. And of course, this case shows that okay, so k-means, how do you know that for a data set you have, how to know that what are the number of clusters you already have? So to overcome this problem, we use a kind of optimized method of it, which is called as elbow method. So what we do is we provide a range for 1 to 11, and we try to see from the graph where elbow method is the method from is a graphical method from where we check where WCSS, it's the error, is the minimum. So we choose that point as the number of clusters. So at 2 it is elbowing, it's the graph is shifting, so this 2 is considered as number of clusters in that particular algorithm. And simply these so k-means is the actual k-means is the algorithm, and we are initializing a number of clusters, and random state is 42, is basically taking the seed, and we are appending the WCSS, which is the error. And at last we are plotting and plotting the graph, which we have already seen in the earlier slides. So at last we know, that we got around 2 to 3. In between 2 or 3, you can either take 2 or you can take 3 as well, because the graph has shifted here and here. You can see like you can see depend on the graphical graph visualization what looks better, and you can go with that. And k means here we have I have taken number of clusters equals to 3, and then we are fitting the model. After fitting the model, the number of cluster, so these are sky blue points are the centroids which our algorithm has considered, picked randomly, and all other are the data points in its cluster. So this is blue cluster, this is green cluster, and this is red cluster. Next is hierarchical clustering. So hierarchical clustering, it seeks to build a hierarchy of clusters, and it has two types of algorithms. One is agglomerative and second is recessive. So in agglomerative, we have individual clusters like A, B, C, D, and E, and then it repeatedly executes the following steps. First is identify the cluster which are very in the closest together, and put those two clusters together and merge those two similar clusters, and this iterative process continues until all clusters are merged together as shown in the diagram. So basically similar initially we have A, B, C, D, E clusters, then it tries to pick one cluster, identify the distance between each cluster to with respect to all clusters, and it tries to pick the least distance. Suppose it has A and B, it has it closest proximity, so it considered AB as a cluster. Now it again starts with C, D, and E, which are the remaining like which has the smallest distance, and again it tries to cluster closest proximity data points. And similarly, of course, after we get this cluster, and of course it is a repetitive process, so this process continues till all the clusters, all the data points in the present in the data set comes under one cluster, and that's how the algorithms overall works. And in the divisive approach, it is kind of opposite. It is just the opposite in a sense that it starts with one big cluster of data points, and it starts from here, and it splits the data set into two data set based on some condition, and it repetitively splits the data till all the clusters have only single data points. Next is density based algorithm. So density based algorithm is the unsupervised learning algorithm method that identifies distinctive groups, clusters based on the cluster in a data space, is a contiguous region of high point density separated from other such cluster by contiguous region of low density. So what problem we faced earlier was we were in K means that we were not sure how many cluster our data set should have. So in density DB scan, it starts with a random point it starts with any random point, and it calculates. So we initialize, it has two parameters, it's epsilon and minimum points. So epsilon represents maximum radius of the neighborhood. So like suppose I have this data point, and I'm considering like in which radius I have to consider other data points so as to make it a cluster. And minimum number points is like at how many number of data points should include in the cluster to make it a full cluster. So talking about the algorithm, it starts with arbitrary point that has not been visited, and it extracts the neighborhood of that point using epsilon. So here epsilon is 1. So suppose it is the data point, and it is considering all the data points within the radius of 1. And then clustering process starts, and it's marked as so all the data points it is visiting, it is marked as if it is in the range, then it considers as clusters. And else matlab and other unvisited data points are labeled as noise. Later on, if the point is found to be a part of cluster, then its epsilon neighborhood is also the part of cluster, and we repeat the above procedure. So this procedure is repeated until all the points which we have start from here are marked as visited. So it starts from here and it will consider all the other points till all the other data points in the data set marked as visited. Last section is dimensionality reduction. So dimensionality reduction basically from a theoretical point of view, increasing the number of features should lead to a better performance. But in practice, the inclusion of more feature leads to worse performance. And that is because of the curse of dimensionality. The number of training examples required increases exponentially with dimensionality. So what we're trying to do is, we have this X and we're trying to reduce this these number of features to these kind of features where k is very less than the p, this p. This is the x matrix which we were talking about earlier, that x1 x2 x3 and takes l xn are the number of features. So dimensionality can be reduced by two methods. One is combining features using linear or non-linear transformation, and second is selecting a subset of features. So selecting a subset of features basically is a feature selection, which we have discussed in the lasso regression very well. Combining features using linear and non-linear transformation, it works. So it uses certain kind of methods or mathematical function like log, square root, to convert those those function to combine those features into basically combining multiple features into one feature. So one of the important method to used in the dimensionality reduction is PCA. It forms the basis of multivariate data analysis. So statistically, PCA find lines, planes, and hyperplanes in the k-dimensional space. So we have the data in a normal dimensional space, but it approximates all the lines and planes in the k-dimensional plane. That is the least square approximation, which is the approximation obviously of our original data points, making the variance of the coordinates on the same line. So we'll discuss quickly how the PCA works. So here each variable is represents one coordinate axis. For each variable, the length has been standardized according to scaling criterion. So scaling criterion basically means by unit variance. Next step is we consider X matrix, which has X number of features. So here you can see that X1, X2, and X3 are the number of features, number of columns which we are trying to reduce. And how we'll start this process is by doing mean centering. The data can be observed as in here that this is the X1 feature, X2 feature, and X3 feature, and it will start we'll start the process by mean centering. So by mean centering is basically each mean centering means that we mean centering involves the subtraction of variables. So whatever is the variable of value of that variable, it averages from the data, and this leads to repositioning of the coordinate system, which we can see in the next slide. Next, what we'll do is, of course, so after repositioning, we can see that this coordinate system is in k-dimensional space. And the first line it is representing, which is passing through the average of all data points, is our principal component 1, which is the feature which we have reduced. Similarly, the second principal component is also represented in the k-dimensional space, which is orthogonal to the first. So basically, orthogonality represents the it should be perpendicular to the first principal axis and passes through all the average point of the principal component of the first principal component. Basically, it improves the approximation of X data and as much as possible. So in a similar way, we can repeat this process till we find number of features that we have satisfied to work with. Mathematically, we have the data. So how do we actually deal with the data? So we have the data this is the data. We are trying to convert this data first into mean centric. So basically we are trying to get the average and subtracting each point to the separating the mean from each data point. Then we are calculating the covariance matrix. So covariance matrix represents how much a variable, so it had only two features, right? So this is x1 and this is x2. Similarly, this is x1 and x2. So what we're trying to do is we're trying to calculate the covariance matrix. So this is basically the variance between x1 and x1, the feature respect. It is the variance itself. This is the variance of between x2 and x1. This is again the x2 feature. This is the variance of x1 and x2, and again at last it has the variance of telling the variance between x2 and x2 variable. Since the non-diagonal elements in this covariance are positive, we should expect that x and y variable should increase together. So basically these are positive, and if they are negative, they are negatively correlated. So basically they were decreasing together in if these two values are negative. Next, what we'll do is, with the help of covariance matrix, we try to find out the eigenvectors and eigenvalues of covariance matrix, and we'll try to rearrange these eigenvectors according to the eigenvalues. So this eigenvalue is largest, so it will come first, and then it will come second. And similarly, this here I have talked about only I have taken the scenario only two features, but in general we'd have multiple columns like 10 or 12 or even 1000. Then this PCA comes in very handy to use, where we have 1000 number of features, and we are trying to predict the most important feature to predict our target variable. Here I am just representing that feature vector is basically we are reordering and considering the feature vector, and the last value to leave out the smaller, less significant component only have single column. So basically the least eigenvalue of eigenvector has least it has its significant. Last, reduce dimensionality and form feature vector. The eigenvector with the highest eigenvalue is the principal component, is the first principal component of our data set. Last is performance matrix in ML. So once ML model is built, the question arises how we can check the accuracy, the performance of that ML. So there are few error matrix that we try to from which we try to calculate how our model is performing. The simplest one out of it is mean absolute error. So basically mean absolute error is the average of all absolute error. So earlier we took the case that it is the y, actual y, and it is the predicted y, and we were just calculating the difference between of the magnitude of these two vectors and summing up on all number of data points. So basically it, of course, it gives you a value, but it does not give any idea about the direction of error, whether we are under predicting the data or over predicting the data. Next is mean squared error. Mean squared tells you so what's the difference between mean squared and mean absolute error is that mean squared error tells you how close a regression line is to a set of data points. Basically, these type of error are mainly used in regression. In classification, we use other types of error matrix. This squaring is necessary. Here you can see the only difference between this and this formula is this square. And why this squaring is necessary is to remove any negative signs. So here negative and positive are being cancelled out, and it was not able to predict the actual error. But here we are doing the squaring, so the actual negative and positive things are not being cut out, and hence it is giving more weight to larger differences, the data points which have larger difference. So as we take this square, as is written here, the effect of larger error becomes more pronounced than smaller error. Hence, the model can now focus more on the larger data errors. The smaller the mean squared error, the closer the fit is to the data. So mean square error, because of this, square is always positive, and a closer to 0 or a lower value is better. So always a value closer to 0 or around it is considered as a very good model. Next is root mean square error. So root mean square is just the square root of the mean square. It is the deviation of error, and it is basically the normalized. So you can see that it has just in this formula we have just taken the under root of this formula, and it has become root mean square error. So what difference does it make? So it is normalized the distance between the vector of predicted values and the vector of observed value. So RMSE is a good measure when we want to use estimate the standard deviation sigma of typically observed values from a model prediction. So basically it indicates the spread of residual errors. So residual errors is the error which we were talking about, epsilon I in a regression slide which we have talked about. So because our data is not always linear, it has some non-linearity, and that error is being captured by RMSE. Next is RMLSE. So basically this measurement is useful when there is a wide range in the target variable, basically in continuous, when you have a wide range of the values in the variable which you are trying to predict, and you do not necessarily want to penalize large errors when the predicted and target values are themselves high. So it is also effective when you care about the percentage R errors. So you're caring about the percentage error rather than absolute value of error. It is basically most robust to the effect of outliers. So what is the difference? So what I'm trying to say is, here in this graph, you can see that in RMLSE graph, we clearly see that the error increasing rapidly as the error is increasing rapidly as the underestimation of actual value increases. Whereas on the right hand side, the error is not increasing as rapidly. But on the RMSE, it does not take account any of those, like how error are decreasing. It is just simply, it is failed, basically, it is failed to capture any relationship between the predicted value and the actual value. And it is completely linear in the sense that in both of the direction, it is giving the error as 0. R square, I'll consider it as one of the most important score. Basically, it is used for explanatory purpose and provides an indication how good your model is. Basically, it tries to explain how good your regression model performs, how good is your regression model is able to explain your data. So this is the mathematical formula where where numerator is the mean standard error, which we have seen earlier, and denominator is a variance of the whole data. For a regression with an intercept, R2 square is between 0 and 1. Higher the R squared, the more variation is explained by your input base. Basically, higher the value, higher the R squared value, your model is better. The better is your model. Yes. And next is adjusted R square. So the problem with R squared is that it will either stay the same or increase with an addition of more variables. Even if they do not have any relationship with the output variable, this is where adjusted R square comes to help. Adjusted R square penalizes for you for adding variables which do not improve your existing model. Next is confusion matrix. So accuracy, it's great. It performs well on most of the regression problems, but it gives this false sense when your model achieves high accuracy, and specifically in terms of imbalance classification problems. So there comes a term called confusion matrix, which gives us a matrix's output and describe the complete performance of the model with the help of a few terms which we are going to discuss further. So a 2D table is created with it has two positive, false negative, false positive, and true negative values. So true positive represents that if the instance is positive, it belongs to the positive class. and it is also predicted by the model as positive. First, negative is the class of data points in which the instance is positive originally, but your classifier has detected as negative. Basically, it predicted your actual target variable as in the wrong class. Third is true negative. True negative is the instance where your actual data point is negative. It belongs to the zeroth class, but it is and it is also classified as negative. So negative class is classified as negative. And false positive is the class where your instance is negative, but it is misclassified as positive. So there are few terms that we can calculate from this table, which are true positive rate, which tells us about how many selected items are relevant from the data you have given. So basically, it is the ratio of positively correctly classified instances to the total number of positive instances. Next is precision. Precision tells you like how many relevant items are selected. So basically, precision tells you the ratio of correctly classified positive instances to all the positive classified instances. It takes consider all the positive instances. These are the mathematical formula, which is TP divided by TP plus FN. So basically, true positive divided by true positive plus false negative, and false positive divided by true negative plus false positive. So why we are using accurate this confusion matrix instead of accuracy, which we have discussed earlier in terms of classification problem? The limitation is that if you consider a binary problem in which you have two classes, number 0 and number 1, and your class 0 has almost 10,000 examples, and your class 1 has only 10 examples, then it leads to imbalance, because your, of course, accuracy, suppose your model predicts 9990 all the examples correctly, so your accuracy reaches 99%, but your model, but of course you see the accuracy is very high and you will think that your model is performing very well. But the problem lies that your model is only predicting this class very well, but your model is not able to generalize over this class which has less number of data points, and therefore this accuracy in these kind of scenarios is misleading, because your model does not detect any class 1 example. Sensitivity and specificity are again two terms, which is defined as the again true positive rate, and specificity defines as the ratio of true negative instances which were so true negative instances means the instances which were actually negative to the total number of negative instances. Last but not least, I guess, F1 measure. So F1 measure is the harmonic mean of precision and recall. So higher precision but lower. So basically F1, the F1 score tells you like how precise your classifier is, how many of your instances it classifies correctly, positive into positive and negative into negative. And it is robust because it does not miss a significant number of instances. So earlier in accuracy, we were saying that it only focuses on the class which has number of data points more, but in F1 score it also pays attention to the class which has less number of data points, and that's why F1 measure is a good metric to check your ML models on classification problems. Last, area under curve. So ROC graphs are the two-dimensional graph in which true positive rate is plotted on y-axis. So this is true positive rate, which we have discussed earlier, sensitivity, and it is false positive rate. And ROC depicts the relative trade-offs between the benefits. Benefit means true positive and cost false positive. So basically, what we are trying to say is that AUC and ROC is a performance measurement for the classification problems at various thresholds. So it tries to, we have this, so we talked about that classification logistic regression works on certain thresholds on which we try to classify a particular those range of values into two categories. So it tries to find out the best threshold to classify your data points. So basically ROC is a probability curve and AUC represents the degree of measurability. It tells you that how much your model is capable of distinguish between your classes. Higher the AUC, the higher your model is predicting zeros as zeros and ones as ones. Last topic of this session is applications of the machine learning. So there are various applications in many domains. So I'll cover it one by one. One is the healthcare. So healthcare, basically in one of the main application of ML in healthcare is the identification of and diagnosis of the diseases and ailments in its earlier stage, like cancer or other genetic stage. So these are the these are the areas where AI is performing or AI is being used. Next is medical imaging diagnosis. So machine learning and DL are both responsible for the breakthrough technology called computer vision, if you have heard about. So computer vision basically deals with the image data set of basically non-structured data set. And as ML and AI becomes more accessible to other users, of course we expect to see more data sources, varied medical, if specifically in medical imagery, becomes a part of this AI driven diagnostic process. So basically, as more users are using this AI, so it is expected more to have more such kind of AI driven solution to these kind of problems. So basically medical imaging in its from its scratch takes very much of time, and it's a time consuming process for doctors. But AI, it can help the cost as well as it can reduce the cost, and it can help the doctors to treat the patients at its on its early stage. Third is drug discovery and manufacturing. So one of the primary clinical application of ML lies in early stage drug discovery process, which includes next generation sequencing and precision medicines. You are very familiar with the COVID-19 situation and how AI helped is that it how AI helped in its drug discovery is it has tried to predict the right sequence for its specific drug. So the vaccine which we are talking about, so it helped in creating that, determining the patterns of that specific virus and creating the anti-drug, antibacterial to that. The last is outbreak prediction. Everyone, of course, as I already listed out the COVID-19, that AI-based technologies are also being put to use monitoring and predicting epidemics around the world. And I would say COVID-19 is the best example that I can list out right now. In other areas, manufacturing. So perfecting the chemical yield, basically perfecting the chemical yield is, so big data solutions are being used, and specifically the sensor data, to analyze every factor that impacted the production output. So basically different kinds of every factor here, if I meant, is the amount of carbon dioxide, oxygen, nitrogen, different kind of parameters are being detected to see the impact, how production changes. Next is vehicle quality assurance. So vehicle quality, so BMW, you must have heard about the BMW, have been using big data to detect flaws in its cars since 2014. And by using this AI driven technology, not only it has created its brand value, but reduced its cost to much extent. And it is what a very much explored domain in which AI can be explored. Third is designing a jet engine. Of course, Royal-Royce is a very famous user of big data technology. So it helps. So what they're doing is they're trying to manufacture new aircrafts using AI. So what motivates them to use it? So it helps them to know the strong sides and weaknesses of a model, of an architecture, long before it is scheduled for production, hence improving the quality of products and lowers the cost.
Aishwarya, I'm sorry to butt in the middle. The session is about to be ending, so I just want. Yes.
Yeah. I'll wrap up in 1 minute.
Oh, thank you.
Yeah. So lastly is e-commerce. So everybody is familiar with Amazon, Google, how personalization happens, where we get the user experience, personalized user recommendation, and show how recommendation based on their preferences. Next is improve customer service. So instead of human, we are using chatbots today. Chatbots to actually solving out your daily problems, your direct queries. And by using AI-powered algorithm, we can perform quantitative prediction, which makes sure that our process it goes smooth and it pays off very well. Last is finance. So for most companies today leverage machine learning to flag and combat fraud detection and prevention, and by scanning their large data set to detect unique activities and anomalies. Next is loan underwriting. So loan underwriting is whether by using the data of a customer, you can analyze whether you should approve loan for a particular user or not. Self-driving vehicles, of course, it's one of the biggest boom right now. It makes possible self-driving cars to exit because they allow a car to collect data on its surroundings via camera and other resources, and those cars try to interpret those data and decide what action to take on. And in this case, we can understand it very clearly that these cars are trained with the data they have collected from their surroundings, and they are very much trained to take these kind of important decisions as well. Others are astronomy. Others area in which AI can be explored are astronomy, gaming, data security, social media, Facebook. Of course, people you may know, that segment where you can see the people are being recommended to you. Automotive industries and agriculture, etc., are some of the areas where AI is doing wonders right now. Thank you. That is the presentation for today. If you would like to if you have any question, please do ask.
So thank you so much, Krishna and Aishwarya. The session was very interesting. However, we have no much time left at all.
Yeah.
But I'm sure they can catch hold of Krishna and Aishwarya, both of you guys, on the lounge section. There are a lot of questions been popping up. And they also are looking to get a hold of the presentation that has been shared today. So if you guys can tell them how to get hold of that, please.
Sure. So we will be sharing these all the codes which are being shown in the presentation on the, I guess, on the platform itself.
Okay.
Yeah, along with the and of course on the YouTube we'll provide all the links in the description below. You can check that out from there.
Correct. The session has already been streaming on the YouTube. So if any of you guys have missed any part of the session, please go there and check the Analytics India Magazine YouTube. Thank you, Krishna and Aishwarya, again for doing this here. Thank you.
Thank you.